Okay, perfect. Thank you. So before we start, let me tell you the agenda for the day. So we are going to start the image analysis, or rather the using deep learning, and we'll see what are the different uh, evolution history for CNNs and related neural networks, and what is the state of the art models for image analysis, and also CNN, like how it looks like from internal, what are different kinds of layers. Okay, and then we will implement an example using some standard data set. So that's the agenda. But before I get started, any questions on RNNs or whatever we have done so far? कोई नहीं run कर पाया है, कोई error आ रही है, please ping me. We will take 10 minutes and then we will go ahead. Any question, please, guys, ask me right now. Okay. So then let me ask the questions if people don't have. Okay, guys, if anyone have question, let me know, or then let me ask otherwise. Can you tell me what are the different ways of doing embedding, word embedding? Guys, please answer the question. Okay, good, very good, Karan. Perfect. Other people, what are different ways of doing word embedding? You have an embedding layer also, right? The embedding layer was there. Can anyone tell me the parameters for the embedding layer? Order matter नहीं करता है, just tell me the parameters. आप क्या पास करते हो उसमें? Guys, just attending this class is not going to help anyone. Okay, unless you are able to answer the questions or practice it. Yes, Karan. But actually I am looking more for the specific word, the specific terms. Guys, you can open the notebook and just try question mark, read it, ping me, please. I'll take 4 or 5 more minutes before going to CNN. Okay, let me recall it for you so that you can answer it quickly. So when we talk about the natural language processing, okay, जिसमें हम बात करते हैं कि एक मशीन है जो मुझसे बात कर सकती हो, राइट? या फिर एक मशीन जिसको मैं बोलूं एक नया गाना लिख दे या नई स्टोरी लिख दे, तो ये सारा NLP है, NLG, NLU हो गया कि एक मशीन जो मुझसे बात कर सकती है. नेचुरल लैंग्वेज अंडरस्टैंडिंग. नेचुरल लैंग्वेज जनरेशन क्या हो गया कि एक मशीन ने नया गाना लिख दिया या नई स्टोरी लिख दी. ओके, वो हो गया NLG. ओके, नेचुरल लैंग्वेज जनरेशन. या फिर एक वीडियो चल रही है उसके सामने, उस वीडियो को देख के समझ के फाइनली कुछ स्टोरी लिख देना. ओके, वो भी एक नेचुरल लैंग्वेज जनरेशन का पार्ट है, जिसमें इमेज एनालिसिस भी यूज होगा ऑब्वियसली, which is another thing. And in this field there are multiple networks like RNN, recurrent neural network. और recurrent neural network के बहुत अलग अलग तरह के आर्किटेक्चर्स हैं, जिसमें मैनी टू मैनी, मैनी टू वन, वन टू मैनी, राइट? इस तरह के आर्किटेक्चर्स की हमने बात की थी. ओके, जब हम इन आर्किटेक्चर्स की बात करते हैं तो अल्टीमेटली उनको इंप्लीमेंट किया गया यूजिंग LSTMs और ग्रूव्स। हमें पता है कि ग्रूव और LSTM में फर्क क्या है। 2 गेट्स हैं, एक में 3 गेट, प्लस उसके अलावा क्या डिफरेंस था ग्रूव में और LSTM में? ग्रूव के गेट्स का नाम कोई मुझे बता सकता है? ग्रूव के गेट्स का नाम? यस विपुल, रीसेट एंड 2 गेट होते हैं ना? अपडेट, वेरी गुड। और LSTM के? लेट्स स्टार्ट विद द फॉरगेट गेट, इनपुट गेट एंड आउटपुट गेट। यस करेक्ट करेक्ट, वेरी गुड वेरी गुड। उसके अलावा क्या फर्क था? LST में देयर वाज समथिंग एडिशनल, राइट? व्हेन वी टॉक अबाउट ग्रूव, वो चीज उसमें नहीं थी। LST में देयर वाज समथिंग एक्स्ट्रा, व्हाट वाज दैट अदर देन गेट? Yeah, cell state, or you can say it's cell, memory cell. Okay, the memory cell which is there. C, hidden state होती है, memory state भी होती है, या cell state भी होती है। Okay, प्लस LSTM लॉन्ग टर्म पैटर्न्स को समझने में, मेमोराइज करने में बेटर है। ओके, short term and long term both, so that's another thing. Okay, and then we were implementing these models, we were using these layers, whether we want to use a GRU layer or a LSTM layer, and then we know that there was an additional layer which was embedding layer that can be avoided if you want to do embedding on your own. Okay, embedding को visualize करने के लिए हम क्या use कर सकते हैं? What can be used to visualize the embedding? Word embeddings? PCA, good Vipul. Anyone else? How can you visualize word embeddings? Yes, Karan, good. Okay. And word embedding, how it identify the similarity of words? Okay, okay, perfect. Now the another point is, instead of using one-hot encoders or one-hot representation of words, why we use the embedding? Like, what's the benefit of using embedding? आप वो embedding में एक feature representation देते हो, right? एक feature vector बनाते हो। Instead of saying 010101, आप कुछ probabilities वहाँ पे type in करते हो। Yeah, both of you are correct, Karan and Vipul. The first point is definitely to reduce your dimensionality to only the feature space. Like, हर एक वेक्टर की जो लेंथ है वो जितने आप फीचर बोलोगे उतनी हो जाएगी, like 10, 20, 300, 400, इंस्टेड ऑफ वोकेबलरी के साइज से वो कम हो जाता है। वोकेबलरी का साइज बहुत बड़ा होता है, और डेफिनेटली दैट्स गोइंग टू गिव यू द कोरिलेशन बिटवीन द वर्ड्स। जब आप एक 2 डायमेंशनल ग्राफ में देखते हो तो जो वर्ड्स क्लोजर दिखते हैं मतलब कि वो सिमिलर है, तो वो बेस्ड ऑन सर्टेन सिमिलैरिटी मैट्रिक्स वहां पे प्लॉट किए गए हैं, राइट? उनकी जो वैल्यूज हैं कोसाइन सिमिलैरिटी के बेसिस पे सिमिलर जो वैल्यूज आइडेंटिफाई हुई, दे वर प्लॉटेड ऑन दैट टीसनी और PCA ग्राफ। perfect. सो गुलजार, 2 आंसर हैं। एक ये कि हमारा डायमेंशनलिटी स्पेस कम हो जाता है, जिससे कि आपका मेमोरी वगैरह सब बचता है। ओके, मेमोरी, कंप्यूटेशन, एवरीथिंग इज सेव्ड। ओके,
सर जैसे जब
एंड
आप
द
किसी
सेकंड इज, हाँ
सर ऐसे जब
बोलो
आप
बोलो।
किसी के आंसर पे फीडबैक तो देते हो कि अच्छा कि गुड या परफेक्ट आंसर है, पर वो पता नहीं चलता आपने किसको कहा है, क्योंकि उसने सिर्फ आप ही को भेजा है, तो उससे कंफ्यूजन उसमें।
हाँ हाँ, नो प्रॉब्लम। मतलब आप अपना आंसर पिंग कर दो मुझे। मैं किसी को, मतलब आई एम नॉट गिविंग एनीवन दिस थिंग feedback on that. I'm just asking the question. So I want all of you to answer. Okay. तो जो आंसर दे रहा है, मतलब that's only for that person. But yeah, I'll try to help you, Gulzar. I'll take care of that. Your point is also valid, definitely. But yeah, Gulzar, to answer your point, the first one was to make sure that the words are related to each other, and the second one was to reduce the dimensionality. We use word embedding. But guys, there is another thing which is known as character embedding. Uh, you can note it down and read it. There is something known as character embedding. There are some specific cases where that is also done. So you can just note it down. Somewhere spell corrections and all, and multiple other things. So like you have word embedding, there is character embedding, which is used. Or word to vector. Okay, what we did here was the embedding layer and how it works. Okay, and then I asked you guys to read about TF-IDF, the term frequency and inverse document frequency, which is another algorithm along with LDA. Can anyone tell me the full form of LDA? Latent direct allocation. Okay, perfect, Alvi. Okay, guys, so thanks a lot for all the answers. I would like more of you to implement these RNN models and implement it via multiple layers. You will see millions of parameters जो कि train होते हैं आपके model में, millions of parameters, right, across the layers, which get computed. So आपके model को time लगता है यहाँ पे. Then in the last class we talked about callbacks. Because you're using Keras and TensorFlow, there are certain callbacks, like you can do model checkpointing to create .h5 files, and then you are also able to do some learning rate reduction, right? Like constant learning rate ना रख के आप उसको reduce करते रहते हो. And then there was a tensor board thing where you can visualize what's happening behind the scene, how your loss is reduced after every epoch. Okay, and tensor board आप अपने local machine पे चला सकते हो. टेंसर बोर्ड हम CNN में भी चला सकते हैं because underlying layer is TensorFlow. So we will see here also how tensor board will work. But yeah, so let's get started. So guys, today's topic is very interesting, which is like computer vision. And in the field of computer vision, there are multiple models that we will talk about. Definitely we will not implement all. Okay, so let's start with the computer vision. So computer vision, we all know, is very important in today's world because we want to make things more secure, as in by using your fingerprints, by using your iris scanners. That's where computer vision comes in picture. So computer vision can scan the documents, images to get the content out of it. You can analyze a video also using computer vision approaches. You can build a self-driving car. You can build security systems in prisons where if a person is making movement in a particular area, you can put guns and fire it, kill him. Okay, so a lot of things are happening. मतलब क्या करेंगे कि फेंसिंग पे एक गन्स लगा देंगे सिक्योरिटी के लिए, एंड इफ देयर इज एनी मूवमेंट किल दैट थिंग. बट नाउ अब वहां थोड़ा इंटेलिजेंस बिल्ड कर सकते हैं हम कि कुछ भी अगर वहां हो उसको किल करना है, या एक पर्टिकुलर टाइप की चीज हो. मतलब डू यू वांट टू किल ह्यूमन ऑल्सो? नो. अगर आप अपने घर के चारों तरफ एक फेंसिंग बना रहे हो, मान लो देयर इज अ फार्म, यू वांट टू पुट फेंसिंग कि उसमें कोई टाइगर या लायन ना आ जाए, तो you will put guns, but that guns will only fire when it see a animal which you have trained model on, instead of killing any moving object or person. So that's where computer vision becomes more and more intelligent. There was this thing like I think somewhere in Western country, one of the Western countries, maybe Alaska or somewhere, maybe they wanted to build a model that can predict फॉक्स. ओके, बिकॉज वहां पर स्नो होता है और स्नो फॉक्सेस बहुत होती हैं, तो दे वांटेड टू बिल्ड फेंसेस टू किल दिस फॉक्सेस. but what they realized was that even some of the dogs, they were being identified as foxes because of their looks. तो ये बड़ी प्रॉब्लम है कंप्यूटर विजन की फील्ड में कि data set is very important, because sometimes some things they have very common feature. So you don't want to kill a dog, you only want to kill a fox, okay? Or you want to kill a tiger or a lion but not a cat. So that means आपका data set बहुत ही powerful होना चाहिए to understand all the content that you want. तो इस field of problem को हम कहते हैं image classification, जहां पर आप image को identify करना चाहते हो ये image कौन सी है. There is a very famous thing that Google do, clouds that we see, right? Clouds के भी बहुत तरह के प्रकार होते हैं, okay? और उसके basis पे Google has built a image classification algorithm just by looking at the cloud, which kind of cloud it is, cloud shape को देख के, and then there are some features associated with these clouds, so they want to identify. So that's another fun thing you can look at. So those of you who have account on GCP, like AWS, there is GCP, Google Cloud Platform, GCP. So there you will get to see this algorithm, a cloud image detection algorithm. But I'll just tell you. Okay. So you guys can have a look at it later. It's currently not showing me definitely those cloud shapes. Yeah, leave it. Okay. So there are these cloud detection algorithms which can be used. I'll show you later maybe. Yeah. So these are some of the image detection and classification algorithms. After that, the second category of algorithm that comes is, which is known as object detection. Now what is object detection? Seems similar, but object detection का purpose ये नहीं होता है कि मुझे ये बताना है कि it's like a cat or a dog. First of all, the main purpose is if there is any object in front of me, if that object is moving or stationary. So that's like you identify the objects. Like if there is a self-driving car, it want to avoid all the objects in front of it. So what we do in object detection is we build these squares or rectangles around each image. This you see red here. So what we do is our camera, it identify all the objects and segregates them, like okay, this is one object, this is another object, so that it can easily maneuver from this path and can avoid any collision. Even the trees are also the objects for it. Okay, everything is an object. Even the what you say, zebra crossing or the crosswalks, red lights, everything, it will just build some blocks around it. आप लोगों ने देखा होगा ये सेल्फ ड्राइविंग कार के अगर कुछ वीडियोस देखे हो. It builds this कि हाँ, there are some objects and my purpose is to just avoid them, okay, or follow some, like if there are some red lights, so it will follow those rules. It's a different case. But yeah, if it's only about passing through, it will. Yeah, Gulzar, yes. Self-driving car may or may not be driverless. दोनों अलग चीजें हैं. सेल्फ ड्राइविंग कार में आप हो सकते हो, ड्राइवर हो सकता है, बट ही मे नॉट बी ड्राइविंग इट. मतलब ड्राइवरलेस अगर हम कहते हैं तो कंप्लीटली फिर हम उसकी बात करते हैं जहां ड्राइवर है ही नहीं. ओके, बट नाउ इट इज लाइक टेस्ला, व्हाट दे से इज लेट द ड्राइवर बी देयर, बट इट्स लाइक यो है ऑटो फ्लाइट मोड जैसे रहता है प्लेन में. तो बट पीपल इज सेम, बट दे आर नॉट सेम.
सर तो जहाँ पे ड्राइवर है इसका मतलब ड्राइवर सिर्फ गाड़ी की फंक्शनिंग को सुपरवाइज करने के लिए बैठा है.
हाँ, मतलब समटाइम्स व्हाट हैपेंस इज कि मशीन जो होती है, machine can take wrong decisions. You also want to have a human intervention, like autopilot mode है, but फिर भी pilots हैं plane में, right? So as to make sure कि आप पूरी जर्नी में autopilot नहीं कर रहे हो, कुछ particular instances पे autopilot कर रहे हो. Okay, but सेल्फ ड्राइविंग कार बनाने का पर्पस यही है कि आने वाले समय में वो ड्राइवरलेस हो जाए. गेटिंग इट? लेकिन अभी we are not at a stage where we build a driverless car. We can build a self-driving car, but we still need someone to have to be there. Yeah, people. Means the purpose is to go to driverless, but we are not yet ready. Tesla also killed, I don't know, but I heard Tesla also killed a few people, 1 or 2 during their testing, but I'm not the right person to tell that unless I check it. But yeah, so that's why these things are still in the phase of experimentation. Means I think it overspeeded and it collided somewhere, that car, and the driver was killed or the passenger was killed, something like that happened. Okay, so this is about object detection. आप लोगों ने देखा होगा जैसे फेसबुक, राइट? व्हाट फेसबुक डू, आप जो भी फोटो डालते हो उसमें वो आपके फ्रेंड्स को टैग कर देता है, राइट? तो कैन एनीवन टेल मी कि वो ऑब्जेक्ट डिटेक्शन है या इमेज क्लासिफिकेशन है? एज सुन एज यू पुट फ्रेंड्स, वो उनके जो फेसेस होते हैं उन पे टैग्स लगा देता है. इज इट डिटेक्टिंग द ऑब्जेक्ट्स इन योर इमेज और इट्स क्लासिफाइंग दोज पीपल? ओके, image classification. Oh, perfect. So it's image classification, not object detection. Perfect. Now after this there is another field or another kind of problems which are style transfer. Just take it like style transfer. Style transfer is when you have 2 images and you want to combine them to create a third image. So that's also known as style transfer. You are transferring this style on this image and then creating a new image. That's also can be solved using the computer vision or the neural networks. So that's a style transfer or neural style transfer. There is another thing, fourth one, which I'll tell you is, if say I give you half of the image, if I give you half of the image and ask you to build the remaining part of the image, that's the fourth problem. And that can also be solved through neural networks. I only give you half of the image and ask you to build the remaining image. This is some of the research area, but we have good algorithms already. Okay. So computer vision के 4 basic problem statements हमने समझे: image classification, object detection, style transfer, and completing an incomplete image, like that. Okay. या इसको इस तरह से समझ सकते हो, जैसे मान लो आप कोणार्क सन टेम्पल गए and you click its image and the algorithm builds it जैसा वो शुरू में था, क्योंकि आज सन टेम्पल बहुत ज्यादा टूट चुका है. लेकिन अगर आपका CNN मॉडल या एल्गोरिथम उसको देख के बिल्ड कर सके कि आज से पहले कैसा दिखता था ओरिजिनल स्टेट में, तो दैट्स व्हाट आई एम टॉकिंग अबाउट, जनरेटिंग द ओरिजिनल फॉर्म, ओके, बैक फ्रॉम द ब्रोकन or maybe इमेजेस जो कि फेक हो चुकी हैं, खराब हो चुकी हैं, which is where even archaeological departments they should use these things. Okay. Okay, these are the 4 areas. So style transfer in general is when you have two images, you want to superimpose them, एक दूसरे के ऊपर इमेज लगा के एक नई इमेज बनानी है. जैसे ये भी होता है ना कि आप अपनी फोटो और उसको एक पर्टिकुलर कार्टून कैरेक्टर की फॉर्म में कन्वर्ट करना चाहते हो, तो यू to be superimposed together. And people are like, one of them is working as a chief AI scientist with Facebook. I think this guy's with Microsoft. You can check. Anyways, it's with big universities. Okay, let's talk. So again, I'm talking about RBMs, which is restricted Boltzmann machine given by Jeff Hilton. Start one by one. First of all, you should be aware about this person, Jeff Hilton, sort of a father of computer science field, and his students, okay, along with him, like Ian Likun and one more, they all got a very famous prize again. Okay. Yoshua Bengio. So there's a thing, right? Famous award in the field of computers for their work in the deep learning neural networks. They got this. And Yoshua Bengio. So let's go back to this again. And see, his name always comes with it because he was the one to bring it. So अभी ये इतना यूज आगे बहुत ही माना है. Okay. So here normally talk to units, or if you get layers. This is a neural network. आपको दिख रहा है if you get this visible layer and the hidden layer. only the visor and the hidden layer. And what they are trying to solve is you are passing an image, how to understand what this image is. मतलब इमेज में ऑब्जेक्ट क्या है या इमेज में पर्सन क्या है, एनिमल क्या है, whatever. So they used to have a visible unit and a hidden unit, where visible unit was like you are passing your inputs, यहाँ पर कुछ weights होंगे, some calculations will happen, input will be, and then there will be this hidden unit which further like you have a forward pass and a backward pass, but there was no gradient very late in the field uh, by Yen Lee Kyun. We will talk about this guy. Was building this machine where there was forward passes and the backward passes. Back passes were not the algorithms. So you used to pass the input. It used we used that. मान आपने से कुछ इनपुट दिया, मान लो 2, आउटपुट आया 3, ये हो गया 3 को अगर यूज किया जाए तो ये वापस की जर्नी में क्या जनरेट करेगा, ओके, एंड से इट जनरेट समथिंग लाइक 2.1, तो वी अंडरस्टैंड दैट इट्स गोइंग than convolution layers, there are 2-3 more important layers. We will talk about pooling layer. Okay, there is pooling दो तरह की होती है, max pooling and average pooling. We will talk about that. It's optional. This is optional, but this is mandatory layer. This is optional. Then again, this convolutional layer, which is there. And finally, we will have our dense layers before we generate the output. For example, here we have to identify what is this object. We want to say, okay, this is a car, or whether it's a truck or a bullock cart, whatever. So we will pass this image through multiple convolution layers, 1 layer, 2 layer. Finally, whatever the data we have generated, the feature vector, we cannot use this convolutional layer output to predict something. Ultimately, तो हमें dense layers चाहिए ही चाहिए. Even in RNN also, add the give only that many output जितनी कि आपको क्लासिफिकेशन करनी है. तो आउटपुट लेयर में 10 आपके पास what I would say न्यूरॉन्स होंगे. So यहाँ पर ये जो फाइनल लेयर है, which is having a softmax function, this final layer which is having a softmax function is the output layer. These are the two dense layers that you have with their own activation functions. We work on that. Can anyone tell me what do you know what is this FC? Any idea? Because I haven't heard about this word anywhere. I tell you. So the major things that we are going to do is here, okay, and how I immediately represent mathematics, like how it's vectors, वो अब आप लोगों को समझ आता है. तो इमेज को कैसे हम वेक्टर, yeah, we will talk about that. Yeah, okay. The next. Okay, talk about this another simple model. What I'm trying to do here, let me explain you. Sometimes we use two CNN models, like we pass our images through two CNN models to finally conclude something. Before I explain you what is happening here, can anyone tell me कि दो मॉडल्स यूज करने के पीछे क्या रीजन हो सकता है? What do you think? आपकी जो images हैं, they will pass through two models, or you will use more than one model. Any idea? For validation, okay, multiple images. गुलजार मैं ये पूछ रहा हूँ कि नॉर्मली हम इमेज डिटेक्शन की बात करते हैं, राइट? हमें एक ही CNN मॉडल इंप्लीमेंट करना होता है, लेकिन ये जो आर्किटेक्चर आपको मेरी स्क्रीन पे भी दिख रहा है राइट हैंड साइड पे, इसमें दो CNN मॉडल्स हैं. ऐसा हम क्यों कर सकते हैं? मतलब उसके पीछे बहुत सारे रीजन है, मैं कोई एक सिंपल रीजन समझना चाह रहा हूँ. ओके, so I'll tell you, there is something known as Siamese model. See this. Yeah. So there is a very famous model known as Siamese model, which uses two models, as in इसमें क्या होता है कि मान लो आपकी दो इमेजेस हैं, एक पुरानी इमेज थी, एक नई इमेज थी, लेकिन क्या ये दोनों इमेजेस सेम है या नहीं? ओके, आई वांट टू एनालाइज दैट. तो आई विल यूज अ साइमीज नेटवर्क. मैं आपकी एक इमेज पास करूंगा इस मॉडल से, और मॉडल मुझे बताएगा, पहला मॉडल, कि भाई हाँ दिस गाय इज, मतलब उसके कुछ फीचर्स मैं लर्न कर लूंगा. फिर दूसरे मॉडल से भी मैं अपने कोई और दूसरी इमेज भेजूंगा, एंड मॉडल को वो इमेज भी यहाँ पर चली जाएगी, एंड देन it will compare those images and tell me whether these two are for the same person or these are two different person. So if you look at, so this is my image, for example, at particular place, this is another place. Model will learn some feature space, pass it here. It will learn some more feature spaces, pass it here. Then after that it will pass it through certain more layers, and it will give me output as same or different. ये हम कहाँ यूज कर सकते हैं? For example, when we want to start transacting based on your face, कि आप किसी मॉल में गए और आपका सामान लेके अपने घर आ जाओ, आपके अकाउंट में से पैसा कट जाएगा. Okay, so that these two people are same or not. So that's what these Siamese networks do. There are two input models to it, both gets two different images, so as to compare whether you are same as the older person you were or not. इसको ऐसे समझो, ये वो इमेज है जो मुझे पता है कि आप हो, ये मुझे पता है कि ये तो आप ही हो, लेकिन अब ये एक नया बंदा आया जो कह रहा है कि मैं राहुल हूं. तो क्या सही में ये जो है पर्सन ये सच बोल रहा है या झूठ? तो मैं क्या करूंगा, मुझे ये फीचर वेक्टर्स मैंने लर्न कर लिए, बनूंगा, कंपेयर करूंगा, एंड आई विल टेल कि क्या पर्सन मैं ही हूं, राइट? मेरे ही अकाउंट में से पैसे कटने चाहिए या किसी और के अकाउंट से कटने चाहिए? और इसको ऐसे भी समझ सकते हो कि ये एक पर्सन आपके मॉल में आया, आपने इसका फीचर वेक्टर ले लिया, लेकिन ही इज सिमिलर टू हुम, यू कैन हैव मल्टीपल इमेजेस ऑलरेडी फॉर यू. ये बंदा जो है वो पर्सन एबीसी है जिसके बारे में मुझे ऑलरेडी पता है, तो इसके खाते में से पैसे काटने हैं, बाकी लोगों को के अकाउंट से पैसे नहीं काटने. So Siamese model is one of the very famous model, Siamese twin model. This is known as Siamese twin model. Okay, होता है ये भी. So that's the Siamese twin model. What we normally talk about. So understand this, guys. In the field of CNN, yes, Nitika, it's like those two layers that you see are two CNNs actually. One CNN is this, another CNN is this. It's not one CNN, it's two CNNs. We are leveraging two CNN models here. Yeah, Nishtha, go ahead. Nishtha, I think you have some question. You can pick, but then we have only one image. Okay. So first of all, I am telling you different architectures of CNNs. Okay, CNN के बहुत सारे अलग अलग आर्किटेक्चर्स हैं, जैसे कि RNN में थे 1 to 1, 1 to many, many to 1, many to many. ठीक है, तो यहाँ पर भी ये बहुत अलग अलग तरह के आर्किटेक्चर हैं, जिनमें हमने एक CNN आर्किटेक्चर देखा. अब हम एक थोड़ा कॉम्प्लेक्स आर्किटेक्चर देख रहे हैं, विच इज अ ट्विन मॉडल और अ साइमीज ट्विन मॉडल. तो इसमें what I am saying, Nishtha, is this is your current image, but this is any past image that I have. So I have two separate images. I already know that this person is Rahul. But now who is this person? Is he really Rahul or not? So that's why the older image will be passed through this, the newer will be passed through it, and they will both be compared. For example, you go to a grocery store and you say I'm person ABC, whatever. So I identify that person ABC's image is already there in my system. Okay, but this is the current image जो मैंने कैमरा से आपकी खींची. And then I'll say कि भाई ये जो आपकी current image है और जो मुझे already ABC की image मुझे already पता है, क्या वो दोनों same है कि नहीं? तो I will pass it through two different layers, compare their outputs to say हाँ भाई ये तो same ही person है. Okay. So there is no single image. There are two images next time. One is the older image, another is the newer image. Okay. Give me 1 minute. So if you start to understand the use cases, you will understand it. Does it always compare only two images? Or... So Gulzar, that's what I was telling you. The purpose of this is to replace, say, your debit card at the ATM by your photo. You will go, you will get the money. You don't need a card. Okay, you will simply may punch in some secret word. It will identify older images for you, compare the current images, and say yes, you are the person, the right person. Or even within sub-seconds, model will compare your images to millions of images at the back end and tell you that oh, you are person ABC. Open up your console. जो आप यूजर नेम पासवर्ड डाल के खोलते हो खुद ही खुल जाएगा आपकी आईज या फेस स्कैन करके. Okay, that's happening. That's already happening. So behind the scene, यहाँ पर तो आपको दो images दिख रही है ना, but model compare millions of images. ये image constant रहेगी क्योंकि ये current image है आपकी, correct? जो उसी समय कैमरे से ली गई है. But यहाँ पर ये images बदलती चली जाएंगी. पहले एक image आएगी, compare होगा, नहीं match नहीं आया, दूसरी, तीसरी. Even आप लोगों ने हॉलीवुड मूवीज देखी होंगी एक क्रिमिनल को आइडेंटिफाई करने की कि भाई ये क्रिमिनल का पूरा हिस्ट्री चेक करो, तो योर सिस्टम कंपेयर्स इट टू लॉट ऑफ इमेजेस व्हिच वर ऑलरेडी देयर विद यू. इवन आजकल तो ट्रैफिक सिग्नल्स पे भी ये होने लगा है कि इफ यू आर पासिंग बाय दे ऑलरेडी नो हु यू आर. Okay, if you are passing by a place, they already know that you are the person who is in this particular place. जो cameras लगे होते हैं, secret cameras or even surveillance cameras, specifically in China, they already know कि भैया आप किस दिन किस समय कहाँ थे. Even without your phone. पहले तो phone से track होता था इंसान, अभी आप के face से track हो रहे हो आप. ठीक है, इंडिया में अभी नहीं हुआ इतना, but it will be there. कि आपने अगर अभी क्या होता है कि अगर किसी गाड़ी ने कोई रूल तोड़ा तो चालान आ जाता है, राइट? वो भी एक इमेज डिटेक्शन ही है, राइट? लेकिन अब ऐसा सोचो कि किसी दिन आपने भी अगर रोड पे कोई ट्रैफिक रूल तोड़ा, यू आर वॉकिंग और आप मान लो जेब्रा क्रॉसिंग क्रॉस कर गए व्हाइल इट वाज अ ग्रीन लाइट फॉर एग्जांपल, तो आपके अकाउंट पे खाते पे चालान आ जाए. अभी गाड़ी अलग है और आप अलग हो. गेटिंग इट? कि एज अ पेडेस्ट्रियन ऑल्सो आपको चलान आने लग जाए. You are not following the rules of the road. That's what this is. I'll give you a very good example which happened recently in America. But before going into that, Any questions? Do the face detection locks in phones also operate on this? Yeah, Prakesha, that's also. But जो फोन में फेस डिटेक्शन होता है जो आप पूछ रहे हो, वो एक बहुत ही प्री ट्रेन्ड मॉडल होते हैं, बहुत ही छोटे सिंपल मॉडल्स होते हैं. दे आर नॉट दैट कॉम्प्लेक्स. बट यस, आपके फोन्स के अंदर भी द मॉडल्स आर देयर, बट उनके वेट्स ऑलरेडी ट्रेन्ड है. आप उनके वेट्स को रिट्रेन नहीं कर सकते प्रगेशा, राइट? उनके वेट्स ऑलरेडी ट्रेन्ड है. That's what the point is. But they can learn to understand your images. Okay. So आपके फोन्स में भी न्यूरल नेटवर्क्स चलाने की कैपेबिलिटीज हैं, बट वो उतनी ज्यादा नहीं है. मतलब कुछ लेवल तक वहां पे भी वेट्स एडजस्ट हो जाते हैं, बट नॉट कि आप पूरा का पूरा मॉडल उठा के रिट्रेन कर दो. दैट लेवल ऑफ कैपेबिलिटी इज नॉट देयर. और उसी चीज को सॉल्व करने के लिए देयर इज दिस एज कंप्यूटिंग इज बीइंग टॉक्ड अबाउट, कि क्या हम एज डिवाइसेस पे, एज डिवाइसेस मतलब मोबाइल, राउटर्स, मोबाइल स्विचेस, क्या जो एंड यूजर डिवाइसेस है उन लेवल पे हम कंप्यूटेशन कर सकते हैं कि नहीं. जैसे कार, दैट्स ऑल्सो एज डिवाइस इफ यू टॉक अबाउट, राइट? तो एज कंप्यूटिंग इज वेरी इंपॉर्टेंट फॉर डीप लर्निंग. एंड दैट्स वेयर मैंने आपको एक डिवाइस के बारे में बताया था, which was deep lens. Deep lens is a device developed by, can anyone tell me this is developed by? स्क्रीन पे भी दिख रहा है वैसे किसने डेवलप किया था, अगर आप वैसे भी बता पाओ. हमने पिछली क्लास में बात की थी. हाँ हाँ, करेक्ट करेक्ट, ठीक है. स्क्रीन पे हमें दिख रहा है AWS Amazon जनरेटेड और डेवलप दिस. कि अगर आप, अभी क्या होता है जैसे कि कैमरा तो घर पे लगा हुआ है कि कौन आ रहा है कौन जा रहा है आप वीडियो में देख सकते हो, लेकिन क्या उस बंदे को हम टैग कर सकते हैं, ये बंदा कौन था? क्या सिस्टम पीछे से इंटरनेट से सर्च कर सकता है उसकी हिस्ट्री? तो वो सब हम डीप लेंस से पता लगा सकते हैं कि मेरे घर के बाहर से अगर कोई गया है तो आखिर वो था कौन, चाहे मैं उसको ना भी जानता हूँ. तो डीप लेंस कैन हेल्प मी डू दैट. Or I can train it on certain data sets, right? If you see that face detection and all these things. Okay. शायद ये 25-30 हजार का आता है, मतलब इफ यू ऑल्सो वॉन्ट टू बाय एंड कोड इट, या थोड़ा और महंगा. ओके, सो यू अंडरस्टैंड दैट दिस इज अ डीप लेंस which is another device. There is this edge computing. I think, Gulzar, this is 99% accurate or even more, which I know recall of. It's 99 or even more than that. Yeah, Vipul, so that's the problem. So but yeah, uh, that's what it is. Okay, so let's move ahead. So we were talking about the history of computer vision algorithms. We started with the Boltzmann machine or the RBMs by Jeff, who is still working in this field. But there was a French scientist, I told you, Yan Liqian, who worked at AT&T Bell Labs to build the first CNN model, came here. Okay, and that is also known as after his name. So it's Lee CNN. So this is one of the famous one. I am removing this Banjo here. Yeah. But after this, Yan Liqian, a lot of other people worked and gave more architectures. So we are, I'm telling you the architectures. AlexNet. AlexNet is another famous architecture for CNN models. After AlexNet, there are another known as ResNets. These are residual networks known as ResNets. and then there is inception model. Okay, these are, and one is VGG. So these are the famous models in the field of CNNs. Okay, guys. So we started with Boltzmann machine in 1780s, and this guy worked for almost 20 years to build this CNN thing, Lee CNN. And after that, things revolutionized, and we got AlexNet, VGG, ResNets, Inception models. Okay, so these are the ones. So we are going to talk about CNN. These are architectures of CNNs, famous architectures of CNNs. So let me go into this before we move ahead. So we have seen what is an RBM. Definitely we didn't went into detail. That's not the even point here. But RBMs were not having any back propagations. There were only two layers. There was forward passes and the backward passes with which this used to learn. Then came this guy with CNN model, and we saw a CNN model. So far we know that in the case of CNN, image, whichever image we have, it's broken down into smaller pieces. If you see here, and each piece is passed through these layers of convolutional layers, I would say. This is convolutional layers. Then there are some pooling layers. We will talk about convolutional layers and pooling layers. What is the purpose of this? Like we had RNN layers, LSTM layers, or GRU layers. So they have their own mathematical operations. So, but at the end, we always have a dense layer, which will be like to do the multi-class classification. Okay. And recently, there is another field of models, which is known as generative models. Generative models, where we talk about GANs. Okay. Any idea about generative models or GANs? Because this is a very famous thing. Excuse me. Did you study about it? RNN की field में भी we talked about GPTs, right? So it's something related to GPTs. Guys, GPTs was what? Anyone? What was GPT? Or what was BERT? Before we talk about this another field, we need to understand the older thing that we talked about. तो देखो यहाँ पर तीन चीजें जो आपको याद रखनी है. एक है RBMs or even older ways of doing deep learning. Then I would say the father of CNN with CNN, and then architectures, and then the generative models, the third thing, which is the current generation of advanced models. But before we talk about GANs, we were talking about GPTs in neural net, rather NLP. But it was from transformer. Very good, Anam. What we were talking about was, हमने कहा, मैंने आपको बोला था कि ट्रांसफॉर्मर मॉडल्स या अटेंशन मॉडल्स होते हैं, राइट? अटेंशन मॉडल्स में एक एनकोडर होता है, एक डिकोडर होता है. एनकोडर का मतलब यहाँ पे इनपुट जाता है, फिर इसका जो आउटपुट होता है वो यहाँ इनपुट जाता है, एंड देन यू गेट सम आउटपुट्स, राइट? बट आई टोल्ड यू पीपल ब्रोक देम इनटू टू पार्ट्स. कुछ लोग सिर्फ एनकोडर्स को अलग ले गए और लेयर पे लेयर एनकोडर की लगा दी और बोला ये बर्ट है, बाय डायरेक्शनल एनकोडिंग रिप्रेजेंटेशन ऑफ ट्रांसफॉर्मर. कुछ लोगों ने बोला चलो भैया सिर्फ ये चीज साइड यूज करके देखते हैं, और उन्होंने जीपीटीज बिल्ड करे. ओके, बट जीपीटीज अपने आप में एक बहुत ही इंपॉर्टेंट चीज बनी. They were generative models, generative pre-trained models. बट ये generative वर्ड बड़ा ही इंपॉर्टेंट हुआ है. जनरेटिव का मतलब क्या होता है कि आपको आधी अधूरी जानकारी दी गई और आपको बोला पूरा का पूरा कंप्लीट करो. मैंने आपको आधी फोटो दी और बोला इसको पूरी कर दो. समझ रहे हो? मैंने आपको आधी नोवेल दी और बोला इसको पूरी कर दो. दैट कैन बी डन बाय जनरेटिव मॉडल्स. दैट्स द पावर ऑफ जनरेटिव मॉडल्स. विद ओनली द हाफ इंफॉर्मेशन दे कैन कंप्लीट. मतलब आपने एक बुक है, उस बुक का आधा कंटेंट इस मॉडल को बोला भैया लर्न इट, एंड रिमेनिंग आधा उसने खुद ही बना दिया. या आपने उसको किसी सिंगर का आधा गाना दिया, it learned it and built the rest of the song, which is almost similar to the original. That is the power of generative. They can generate something. Generate, okay? Like natural language generation, NLG. They can generate something completely new. Generative models. So when we talk about this, GANs is one of the architecture. Generative models is a field, and GANs is one of the example. Yeah, you can say in the field of song or music, not song, music, it's like a remix. But remix भी फिर हम तब बोलेंगे जब मैंने उसको बोला है कि मल्टीपल सॉन्ग्स को लर्न करके या तो ट्यून्स को लर्न करके नई ट्यून बना. तो मॉडल यही तो करता है, मल्टीपल इनपुट्स को लर्न करता है और एक नया कुछ बना देता है. तो एक तरह का वो रीमिक्स ही बनता है. But we are trying to make sure that GANs can be as original as possible, because remix is still not a copyright or a patent because it's derived. But can we make GANs to be original? Like, can we make a model that can learn from the past but build something new, completely new? So that's where we are heading towards, the generative models. Okay. जनरेटिव मॉडल्स कैन इवन डू व्हाट, जो आप मूवीज देखते हो किसी और लैंग्वेज की और वो नीचे सबटाइटल्स आ जाते हैं, दैट कैन आल्सो बी डन थ्रू गैन्स. कि भाई लिसन टू सम वॉइस, कन्वर्ट इट इनटू द टेक्स्ट, but your GANs really helps you to do that. Or even there is a video without even having the voice, just looking at the images, a model can write the story कि images में क्या हो रहा है, वो देख के वो कहानी लिख दे पूरी. That's what generative models can do. They can look at the video without an audio, generate the complete story for you. So story writing GANs or bots can be there. So these are your GANs. GPTs are also used for image analysis also. GPTs जो थे वो मेनली नेचुरल लैंग्वेज के लिए थे, बट हमने IGPTs बना दिए हैं, इमेज GPTs, जो इमेज क्लासिफिकेशन के लिए यूज होते हैं. तो रिमेंबर, जनरेटिव मॉडल्स की फील्ड में एक तो हमारे पास GANs है और एक हमारे पास IGPTs है. ओके, सो लेट्स लुक एट देम. If you see image GPT, so guys, what happened is, I'm talking about generative models using the partial data to generate the complete picture or information. So we have multiple things. So I'm starting with this. I'm talking about IGPTs first. So IGPTs are given by a company, OpenAI, GPTs. And if you look on the right hand side, what's happening is it's just showing you like they had certain partial images and they used it to build the full images. Let me show you this. Okay, so if you look here, guys, they had a model which was trained on some data, and then they gave this input. Okay, they gave this input, and then model built different options. Model built different options for you, and this was the original one. Model generated these 4 options, but this was the original. So if you see how similar it is, even if you look at this cat, model thought of these 4 options. This was the, so let me first bring you this link. I have pinned you this. You can read more about it. It's quite interesting. Thought process. RNN की दुनिया से CNN में कैसे इन लोगों ने मॉडल्स को मूव किया. जो मॉडल RNN के लिए था उसको CNN के लिए कन्वर्ट किया इन्होंने, या इमेज डिटेक्शन के लिए. So if you look at this, you are just passing on some partial images, and that's where we'll say that a model is even capable of generating something far better. Matlab, even if you look at here, the model has built something like this, where उसने कुछ उनकी mirror images या shadows, whatever you say, reflections यहाँ पर दिखा दी. Or even if you look at this one, rather this is far better than the original. So that's where you will see the power of these models. You pass this, but model built something like this or this. Okay, using IGPTs. Yeah, Nishtha, go ahead. Okay, so these are image GPT models. Yes, Nishtha.
Sir, in this image GPT model, let's suppose the third one from the bottom, the chick one. Sir,
Yes.
If this image had a little idea, a little portion of what these chicks are landing on, then it could have automatically guessed the remaining portion of it.
Yes.
Then it would have been completely similar.
Absolutely, absolutely. बट वो तो फिर वही हो गया ना कि आप जितना ज्यादा डेटा पास करते चले जाओगे या इमेज जितनी ज्यादा पास कर दोगे तो ऑलमोस्ट आपने सारा डेटा पास कर दिया. You want to
so
हाँ
yeah. So when we apply this, when we implement,
हाँ, go ahead, go ahead.
So, sir, when we implement these model, this GPT code, so it gives us option 3 to 4 options when it completes that you can choose whatever is the most similar to the original one.
नहीं, मतलब देखो यहाँ पर ऐसा नहीं होता. यहाँ पर हम आपको कोई सिलेक्शन का ऑप्शन नहीं दे रहे. हमारा पर्पस ये है कि फ्रॉम दिस मॉडल you want to generate certain images, and they can be similar, they cannot be. So you want model to generate 4 images, it will generate 4. You want 1, it will generate 1. But consider it like this कि आपको ओरिजिनल पता ही नहीं है क्या है. What I'm telling you is कि आप जैसे you went to Konark Sun Temple and you don't know how originally it looks like. आपको पता ही नहीं है, आपको उसका एक ब्रोकन शेप मिला है, तो आप मॉडल को बोलोगे कि 4 उसके पॉसिबल ऑप्शंस मुझे दे दो. देन यू विल लुक एट कि भाई मॉडल ने क्या बनाया एंड व्हाट यू वांट टू थिंक इज एक्यूरेट एज पर योर नॉलेज, बट डोंट थिंक यू हैव दिस इन दैट केस. क्योंकि मैं रियल दुनिया में जब उसको इंप्लीमेंट करूंगा.
Yeah, sir. So when we get the output of this, when we apply this GPT code, so we are given different outputs or just one output that it has presumed?
No, different multiple outputs. You can control this. How many different outputs you want, like 1 2 3 4, जितने different images आप generate करवाना चाहते हो, क्योंकि generative models हैं, ये इनका output हमेशा same नहीं होगा ना. They can generate you multiple options. तो it's on to you कि आप एक इमेज चाहते हो या मल्टीपल इमेजेस उनसे जनरेट कराना चाहते हो. फॉर एग्जाम्पल, आपने अगर आधी कहानी दी और बाकी आधी उसको लिखनी है, तो इट कैन राइट इट इन मल्टीपल वेज. तो यू कैन से कि ओके गिव मी 3 4 ऑप्शन see which one is good, I'll select that. So model don't know which is right or wrong. Model here are not right and wrong. They are just generative models. They are generating something for you. Okay, but what they are generating is based on the past training that you have given to them, the past information that they have, the past weights that they have learned or adjusted to. Okay, so they have learned it in that way. Okay, let me show you another example. Here the question of right and wrong is not there. Huh? Let me show you. About I don't know how many of you have heard of this auto draw, but let me give you a demo of this. So this is Google's auto draw. I am saying, okay, start drawing. This will be using GAN. Okay, again. I built a box. Okay. Now, if you look at the top, it generated me so many outputs that you are trying to build a box. Okay, it can be this. Look, it gave me this output, right? So here the point is not right or wrong. Here it's creativity. When you are creative, you are not right or wrong. You are generating multiple options, like what people will like, or you can select it like this. So generating models based on their past knowledge, they are suggesting you. If you look at the top, they are suggesting you, okay, what this could be, and now you are generating this. So this is a generative model which is being used by the auto draw. Okay. But when we talk about training phase of these models, so during training phase, definitely we train them on, like we give them, we see what they generate, and then we compare that to the original image during training phase. We compare it, their vectors, and that's where we do backpropagation to adjust the weights. But what I am saying is, when you are generating the actual output, it's sort of a creative output. It's not one-to-one mapping like normally happens. Like कि आप cat की image दे रहे हो तो वो cat ही बोलता है, because वो use case अलग है, ये area ही अलग है, ये field ही अलग है. You understand it, like making your bots more creative. Okay, so they may have learned multiple things. That's even what we do in our life. We learn multiple things, and for any scenario we can have multiple possible outputs, and that's how this particular GANs works. But definitely the outputs that, okay, this is the most, this is the least probable. If you think at the order, for example, you can say that it's ordered by the probability, and then you can select the highest probable or the least probable, or that's on to you. Okay, for example, if I'm just building something like this, it understood this to be, say, the probable thing based on what I built. Okay, so that's how it's working. These are all leveraging GANs behind the scene. So while training, we adjust the weights. Okay, while training, we adjust the weights to compare the images. Okay, but once it's in production, you get the final images. There is nothing like, oh, this is right or wrong. It just, you want to be as creative as possible, options to select from. Again, Harsha, so initially you passed this thing while training the model, and model generated, for example, so you will convert this output into some vector. Definitely it will be in the vector form only, and you already have that original image in the vector form. You will compare them to see the accuracy of the model. If it's not accurate, you will adjust the weights. But वो सारा काम ट्रेनिंग टाइम पे होगा, बिल्कुल होगा, क्योंकि ट्रेनिंग टाइम पे आपको पता होगा कि मैंने ये पार्शियल इमेज भेजी है और उसका रिमेनिंग पार्ट आपको पता होगा ना ट्रेनिंग टाइम पे. तो आप देखोगे कि मॉडल ने जनरेट किया, आप उस हिसाब से आप वेट करोगे, बट वो सही होता है. Question is not of specificity, Gulzar, if you talk about specificity in general, because as I give you, this field is different. If I'm telling you that, okay, you went to say Ajanta Ellora, you build the, you capture the photos and model generate जो टूटे फूटे artifacts हैं, you never know कि original क्या था. It just what could be the best possible way to represent that thing. Okay. And let me give you another example. There was a very famous article I read few days back. Let me check if I can share it. Okay, I'll share it later. I think architectural AI. So in the field of this thing, I'll definitely share it later. But what your bots will be doing is like they will be doing the work of architects. So architects will be replaced by maybe the bots to design aerodynamically stable architectures. Okay, all those things are happening. You can read about it. My main point is to give you some insights. So you look at this architectural AIs, read about it. So the purpose of all these things is a bit different. Huh? Generative models, IGPTs. Let's look at the GANs now. Okay. Like आप लोगों में से कुछ लोगों को deep fake वगैरह का idea होगा, right? Deep fake. So that also uses this GANs and all. Deep fake. Deep fake is another website. I would say. Let me first go into deep fake. So you can read about it. Deepfake generates the, say they take the original image and they generate a copy of it, a fake image of it, and then ask the computer scientist to build the algorithm that can differentiate the two. It is not really easy to do so. Their images are very accurate. Okay. So they can fake audios, they can fake images, they can fake videos, and even the audios also. So they are trying to do all those things. Yeah, so very good point, Gulzar. The purpose of faking we know. But the ethical purpose, I'll tell you. Let's see the GAN and then you will get to understand. The non-ethical side we all know, but let's tell you. Okay. Okay. So how the GANs really works is, if you look at this architecture, how GANs models works is, GAN models have two components. Okay, they have two internal components. One is a generator and another is a discriminator. Okay, a generator and a discriminator. So what you have some real images, okay, you have some real images that you pass to the discriminator. This generator is the person, or the model rather, the part of the model that generates the fake images. Okay, the fake images. So you give some random input based on which this generator will generate a fake output, and the discriminator's purpose is to tell you whether the two images are same or not. And that's where you will get the output from discriminator, whether the images are same or not. But again, if it's not able to do so, the back propagation happens to adjust. That's another thing. But now before we go into this detail, can anyone tell me discriminator का purpose क्या होना चाहिए? Means to tell both the images to be same or to tell both the images to be different? What according to you the accuracy of a discriminator is? डिस्क्रिमिनेटर सही है जब वो दो सेम इमेजेस को बिल्कुल एक्यूरेटली सेम बोल पा रहा है या दो अलग अलग इमेजेस को डिफरेंशिएट कर पा रहा है. ओके ओके now consider a scenario that there was this fake image and there was this real image and model says both are same, discriminator says both are same. Perfect. So that means the discriminator should be trained in such a way that it should be able to learn that the images coming from these two places are different. Okay. So in the case of GANs or generative adversarial networks, we train this model in two phases. We actually train this model in two phases. At one point, we just train the generator and freeze the discriminator. We don't train this. When I say we don't train this, means we don't adjust its weights. We keep them constant. Our whole purpose is to make sure that generator learns. How will generator learn? Generator should generate as much fake images as possible. Okay. So initially generator generates an image. According to you, what should discriminator do? I am getting a real image. I got a fake image. According to you, what should discriminator do? So initially, we are training generator. So the purpose of generator is to break the discriminator. The purpose of generator is to break the discriminator, as in to generate that kind of images which the discriminator can't even discriminate. Mean generator will generate some image, discriminator पकड़ लेगा भाई गलत, ये क्या अच्छा ऐसी बात है. Let me generate more refined, फिर पकड़ लेगा. और रिफाइन 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 तब तक जनरेट करता रहेगा जब तक वो डिस्क्रिमिनेटर फंस ना जाए. At that point we will say हाँ भाई जनरेटर ट्रेन हो गया. Getting it? Then we after that we will freeze the generator but train the discriminator कि भाई ये जो दो इमेजेस तेरे को आ रही हैं डिस्क्रिमिनेटर कहेगा हाँ दे आर सेम. नो दे आर नॉट सेम. यू नीड टू एडजस्ट वेट्स. ओके डिफरेंट डिफरेंट. जब तक वो ये ना बता दे कि यार ये दोनों इमेजेस सही में अलग हैं तो तब तक वो डिस्क्रिमिनेटर के वेट्स एडजस्ट होंगे. तो दैट मीन्स गैन्स और जनरेटिव एडवर्सरियल नेटवर्क्स जो होते हैं they contain certain layers. Train in a two-phase process. First you freeze one part, train another, then you freeze another. Is it getting clear? Okay, so that's what your GANs will do. GANs are actually sort of unsupervised models. Okay, Arshita, I'll do that. But GANs या generative models are actually not supervised models. These are rather unsupervised models where we really don't have much of the targets as in to understand the unsupervised models. But let me repeat it. So just note this term which I said. That supervised models. Try to justify it. Okay. So the question I'm asking you to analyze or GANs are supervised models or unsupervised models. And then if they are unsupervised, which they are, then how can you justify that? Okay, coming back to this, Harshita. Okay, I'm explaining it again. So as I told you, I'm not opening these black boxes because our purpose is CNNs. But yeah, I want all of you to be aware about everything. So I'm not opening the black boxes, what happens inside generator discriminator. But yeah. So what happens here is, let me tell you, there are two components to it which we need to train: the weights. Okay. The weights we need to train for generators and discriminators, but we cannot do that for both parallelly as per the researchers of GANs. So what they have done is they've asked first to freeze this discriminator with whatever weights it has, but then try to optimize the generator. It's just a two-phase process. Yeah, so just have a look here. So what we are doing is initially we are passing some noise to the generator based on which we are asking it to generate some fake data. It generates say some fake data, the say numbers. It keep generating that, but discriminator उसको पकड़ता रहेगा कहेगा कि भाई उसको पता लग जाएगा कि ये रियल है या फेक है. डिस्क्रिमिनेटर का पर्पस है रियल या फेक बताना. तो डिस्क्रिमिनेटर बार बार बोल रहा है वो फेक है. तो जनरेटर हम तब तक ऑप्टिमाइज the generator level is update denominator based on the loss on the real. Okay, and we are updating the generator based on the loss on the generated data. So that's what the difference between the two will be. So Gulzar, I am saying discriminator will initially have some logic, okay, some weights, initial random weights to differentiate the things. And we want generator to be as accurate as the real images. So you can say that deepfake is playing that kind of a role where they can give you too many images, fake images, to test whether your GAN model is good or not. Okay, so deepfake can really help to identify whether my model is really good or not, because it generates me some fake images, gives me some fake images, and then I can use my GAN to really tell me whether those fake images are same as the real images or not. So then के लिए deepfake और deepfake को अगर मैं ethically बात करूं तो then help us to build such models which can be tested to identify whether our model is good or not. So what we will do is deepfake will send you an image here. So instead of this real data, what I can do is I am saying that my model is very good. आपने ये मान लिया, okay गुलजार, आपने ये मॉडल बना लिया, आप कह रहे हो मेरा मॉडल जो है वो जितने भी राष्ट्रपति हैं इस दुनिया के उनके रियल और फेक इमेजेस को डिफरेंशिएट कर सकता है. ओके, तो कहता है अच्छा चलो ठीक है, मैं आपको ओबामा की इमेज देता हूं, आप उस रियल इमेज आपको मैं बोल रहा हूं ये रियल है, और लेट्स सी आपका मॉडल उसको पकड़ पा रहा है कि नहीं. अगर आपका मॉडल कह रहा है कि यार यहाँ, तो आपका मॉडल तो ब्रेक हो गया, क्योंकि ये जो इमेज मैंने भेजी थी वो डीप फेक इमेज थी एंड योर मॉडल वाज नॉट एबल टू कैप्चर इट. I was able to break your model. ये मॉडल किया from deepfake and see if your model is really able to tell me कि मैं आपको कह रहा हूँ ये ओबामा की असली इमेज है, आपका मॉडल भी बोल रहा है हाँ ये असली है, फिर थोड़ी देर बाद मैं आपको बोलता हूँ नहीं नहीं वो असली थी नहीं, मैंने तो आपको डीपफेक की इमेज भेजी थी, आपका मॉडल मतलब सही नहीं है, आपको उसको और ट्रेन करना है. ओके, सो यहाँ पर आपका एथिकल वाला क्वेश्चन भी आंसर कर रहा हूं मैं टू सम एक्सटेंट, बट और भी बहुत यूजेस हैं डीप फेक के, ऐसा नहीं है. व्हाट विल ओके, 1 minute. 1 minute. So that you pass on is depends on the problem statement. It's again some of a web space vector. They already know a certain kind of output, completely on whether you're using it for image generation or audio generation. It's some sort of a vector space. Vector one. Okay.
Sir, whatever the So output is not defined कि हमें क्या generate करना है. मतलब वो depending on the input कुछ भी output generate करेगा.
Output is specific to what you want to generate, as in if you want to generate the images of say Obama, this input will be specific. If you want to generate the images for say APJ Abdul Kalam, that will be different. So what you can consider of this as, in very simple terms, let me say that my model, this is some sort of a model generating images. So I have trained it say on a 10-dimensional feature space, matlab 10, and it can generate images of 10 presidents, 10 presidents, for example. So if I pass all zeros but say one at one place, that particular position represents a particular president. I can pass 10 president values like 0, 0, 0, 0 and 1 for particular president. It's like word embedding, something similar if you think of. So if each of these blue dots representing one of the president name, I'll pass one, it will generate image for that. But it will generate in a random fashion. And then the another point is, do I really want to pass it one, or do I want to pass it as a probability value? So instead of 0, 1, 0, 1, I can pass in some probability values also, 0.5, 0.9, 0.8. So that's sort of a latent space we say, which is again some sort of a vector space, but you're getting it. One of the example I'm trying to give you, later will understand. But it cannot be random. There will be some logic behind it. Okay, you want to generate the images for say this model can generate 100 president images, so I can have 100 long feature vector where each position represents one of the president. But instead again of 0, 1, 0, 1, can I give it like a embedding value? So there is image embedding also, like word embedding. So that can also be done like a probability value. And then this model every time will generate a different fake image. So it can be 0, 1, 0, 1 or something like that, but it's again a vector space, a latent space or a vector space. Okay. Immediately these are not the input, it based on some logic. So there is actually a lot to it. I'm just pinging you the name. These are advanced reasons. So in the field of GANs, which is happening. So in field of it, we have GPTs, we have GANs, then we have enhanced GANs, which are GANs or the enhanced GANs. GANs. Okay. So let me go back to one place, which is neural networks. So let's see how you know by now. Okay, so definitely you don't need to know everything, but yeah, let's see. जब हमने पहले दिन इसको देखा था, from that first day till today, you know that okay, you have neurons, and the neurons makes your perceptrons. मतलब न्यूरॉन एक सिंगल यूनिट होती है, एक सिंगल बिल्डिंग ब्लॉक, लेकिन जब वो कंप्यूट करने शुरू होता है, उसको इनपुट मिलने शुरू होते हैं, तो एक परसेप्ट्रॉन बन जाता है वो। ये मल्टी लेयर परसेप्ट्रॉन बनना शुरू हो जाता है जब हम यहाँ मल्टीपल लेयर डालना शुरू करते हैं, एमएलपी मल्टी लेयर परसेप्ट्रॉन। ये एक सिंगल लेयर परसेप्ट्रॉन है। एक तरह से ये अगर आप देखें तो ये क्या है, एक मल्टी लेयर परसेप्ट्रॉन है, 2 लेयर परसेप्ट्रॉन, फीड फॉरवर्ड नेटवर्क उसी को हम कहते हैं। It can be multiple layers also, सबको हम feed forward ही कहेंगे. This is like feed forward. और इनमें बैक प्रोपोगेशन की प्रोसेस से ये सब अपने वेट्स एडजस्ट करते हैं. तो ये मेरा जो फीड फॉरवर्ड नेटवर्क है ये कोई नहीं है, ये एक आपका मल्टी लेयर परसेप्ट्रॉन ही है, बट ये डीप है क्योंकि इसके अंदर 3 लेयर हो गई. जब भी आपके पास एक से ज्यादा हिडन लेयर हो जाए वो डीप हो जाता है नेटवर्क. एक हिडन लेयर तक हम उसे डीप नहीं कहते, बट 2, 4, 5 मतलब जब भी 2 या उससे ज्यादा हिडन लेयर्स हो तो वो नेटवर्क डीप कहलाना शुरू हो जाता है. Then we also now by know RNNs, where these are your RNN cells and these are your loops. Okay, and oranges are nothing but your outputs, or I would say red are output and yellows are inputs. So, and greens are your hidden units. Blues are hidden units, but not simple neurons. Rather, what they are LSTM blocks, or they are memory cells. I would take it like memory cells. So all blues are memory cells. They have some memory. All blues have some memory. Greens also have some memory, and they also have some looping. So all of these have loops. But grooves have some gates inside it. So triangles and circles just represent the internal difference in the logic. Okay. We are not going into the encoders, but yeah, let's move ahead. Then I told you about this thing, right? Boltzmann machine today. And the most important is this restricted Boltzmann machine, which I told you. So Boltzmann machines are like this, but I told you is about what Geoffrey Hilton built for image analytics is RBM, restricted Boltzmann machine. Only 2 layers. This is rather input. Okay, this is rather input. Huh? There is no separate input layer. Input itself is having a circle. Input, whenever itself have circles, means it's being used for computations also. When inputs don't have circles or triangles, means it just going to the next layer, just pass it to the next layer. But as I told you, there is a forward pass, backward pass, forward back. Input layer या इसको visible layer ये आपस में weights adjust करती रहती हैं. Boltzmann machine is something more complicated. This is RBM. After that, I told you came what convolutional neural networks. Deep is just a word which is like if you have multiple layers between the input and output, there are too many layers, and also 2 hidden layers, so it becomes deep. This is your deep convolutional lead. This is deconvolutional, something other of convolutional things. We are talking about this convolutional layers where you are passing the inputs. It's deconvolutional ones are convolutional layers. I do it through hidden layers. It again goes through some hidden layers or dense layers like Relu and all. And here it must be predicting 3 things, maybe cat, dog, and tiger, something like that. But this pink thing is the convolutional layers, which internally will have pooling, different kind of poolings we will talk about. Okay. And then the final thing that comes is GANs. If you look at generative adversarial networks, so in the GANs, as I told you, this you get certain inputs, but again that data will pass through the generators and the discriminators to get you to the output. And again there will be certain hidden layers, the dense layers, and these are the main computation layers here for generator and the discriminators. Okay, so other than that you really don't need to go into any. Those of you who can anyone tell me, I told you about this also, can anyone tell me ये कौन सा model है? Can anyone tell me ये कौन सा मॉडल है? Very good, Harshita, Aditi, correct. Transformer. It's like transformer model or the attention model, where you have, see, so it's so simple. You're passing in the inputs. These are your encoder sections. You say this is your decoder. Okay. So you have encoders, decoders. So you're passing in the inputs. Some part of it is going into this layer. Okay. So that's like one part is encoder, another part is your decoder, which you will be like using to work on this. But here we don't have birds and GPTs, but yeah, we have the transformer model or the attention model. So that's why you can see two separate parts which are connected to each other. The encoder and the decoder parts, separate parts connected to each other intermediately. Okay, rest all are also good enough, but yeah, I don't want to go into that. Liquid state machines are also good. But yeah, I hope most of these you know by now. So these are no rocket science. Gulzar, yeah, but what was your question?
एक बार वो डिस्प्ले करना जो डायग्राम्स की लिस्ट एक बार
Auto encode. Quite good. हाँ, कौन सा है?
डायग्राम
हाँ, okay.
एक बार वो डिस्प्ले कर दो.
I'll come to that. I'll come to that in a minute. I just want to bring in some things here, right? So restricted Boltzmann machines are okay. So guys, you can go through this document, read about it, how forward and backward pass, not backward propagation. This is backward pass, not a backward propagation, as in no gradient descent. So here you will see this backward forward propagation, but actually there is no backward propagation as in the gradient descent, that kind of the things. That was not available till that. So we'll take a break and we'll connect at 12:25. Gulzar, you can stay for 1 minute. We'll connect after 15 minutes, guys. Gulzar, tell me. I'm going back there. Gulzar, बोलो.
यही थोड़ा सा ऊपर स्क्रॉल. हाँ सर, ये जो सर ये मार्कov चेन और होप फील्ड एक बार
देखो यहाँ पर सारे इनके नाम भी हैं, हर गेट क्या रिप्रेजेंट कर रहा है, मतलब ये कलर ऐसे ही नहीं है लाल काले पीले, मतलब दे वांट टू डिफरेंशिएट देम प्रॉपर्ली.
सर ये जो यही लाइन जो मार्कov चेन और होप फील्ड.
I'm saying that these kernels and this thing, this purple, we will understand today. Convolutions and pooling. So today we will understand what these things are. What is kernel, what is pooling, what is convolutional. आप कौन सा समझना चाह रहे हो? मार्कov चेन समझना चाहते हो?
सर सिर्फ एक क्वेश्चन है, ये मार्कव और हॉप फील्ड और बोल्ट्जमैन के बारे में कि इन तीनों में जो डायग्राम में सिर्फ थोड़ा सा कलर डिफरेंस किया गया है जो
नहीं
मतलब डायग्राम को डिपिक्ट करने में.
Okay. So first of all, there is completely different mathematical operations which happens here. So the color coding represents that mathematical operation. Okay. So in the Markov chain, the mathematical operation, if you look at, is some probabilistic hidden. It's a probabilistic hidden cell. Whereas these yellow ones are the noisy input cells. Not noisy, rather they are backfed input cells. So so this color coding means there are some mathematical differences. Okay, these are not just for sake of coloring. So Boltzmann machine leverages both of the two, the greens and the yellow ones. But if you want to understand what happens in green cell or the yellow cell, you have to uh, open these black boxes and understand it. Markov chain is though very simple. It's not a complicated thing. But yeah, Boltzmann machine becomes a bit complicated. But this is all about the mathematical formulae behind this. Markov chain is not that complicated. It's just to represent the state transfer from one state to another. Markov chain. This Markov chain is used in multiple fields, not only like computer science. Okay, in the field of automata, in the automata theory, we used to study this finite state theory or theory of automata. So if you go to theory of automata, see the very first thing that you see here in the automata theory is still this Markov chain. State 1 to state 2, state 2 to state 1, how you are transitioning from one state to another. So that's even looping is like memory cells. So networks is based on the automata theory or the theory of automata, which itself is a finite state theory or a finite state automata. So we talk about finite state automata. Yeah, Nishta, this is all computer science. If you have majors in computer science, you can understand this. We normally used to have a subject separately as a FSM, finite state machines and finite state theory. Okay, means the states of the system are finite. You can put it through multiple conditions, but only finite states are what a model will go through or a system will go through. So there is infinite state machines also, which is different. This is all computer science. So those of you who are really interested in some research side of the things, they should go into these kinds of things where they'll open this black box to the automata level and see the sequential states are maintained, right? In neural networks, RNNs and CNNs, the sequential states are maintained. How the sequential states are being persisted or maintained based on the automata theory, you can go through it. Okay, we'll connect at 12:30 to open the CNN black boxes. Okay, guys, thank you. Guys, please let me know if you're back. I'm audible. Okay. So let's get started. So what we have done so far is मैंने आप लोगों को in the field of image analysis और image detection with neural networks क्या क्या possibilities हैं जो आप explore कर सकते हो. बोल्ट्जमैन मशीन या के बाद जो आरबीएम उनका आरबीएम से लेके सीएनएन से लेके गैन में क्या enhancements हुई हैं. We talked about that. But now what we are going to do is we are going to implement a CNN model and we'll open this black box कि इसके अंदर formulas calculations होती क्या हैं. What are different kinds of layers. So we first of all need to do image analysis. That means we need to understand the data, how the image data looks like. So all of you please follow along with me. I'm pinging you this code. Please run this. We will take MNIST data. This is very common data. All of the people in this field know about this. हमारे पास कुछ हैंड रिटन नंबर्स हैं, उन नंबर्स की कुछ फोटोग्राफ्स हैं जिनको हमें बताना है कि ये जो पिक्चर में नंबर लिखा हुआ है वो 1 2 3 4 मतलब क्या नंबर है. तो अल्टीमेटली हमारी एक मल्टी क्लास क्लासिफिकेशन प्रॉब्लम है. हर नंबर इमेज में कौन सा है हमें ये बताना है. So this is what the data is. We have multiple images 1 2 3 like that. हर इमेज में एक नंबर है, तो हमें ये करेक्टली क्लासिफाई करना है कि इनमें से किस क्लास को बिलोंग करता है. Okay, this is not a regression problem. This is a classification problem. Okay, so we have image, not object detection or not neural structures or near a GAN, nothing like that. So this is a simple image classification stuff that we are doing. So guys, please let me know if you are able to do this. We will load this MNIST data. The MNIST data will be loaded by the Keras from the internet. This is the path. From the internet, it will fetch this data. We will simply split this data in train test and see the total data shape, what the data shape is. So here we have, if you look at the training data, 60,000 images we have. Yeah, I was inaudible. I was on mute actually. I was not speaking anything. Okay, that's good. So MNIST data is already very famous. So let's just start with this. You guys already know that this is a 28 by 28. Acha, before that, you have done image analytics in R. You have already done this neural network in R. So what you did with this MNIST data in R? Like, did you use this data in R, MNIST data? Some people are pinging me, they have used it. So I'm just trying to ask what you did with that data, this MNIST data in R. क्या था आप लोगों ने? Nistha, can you tell me what you did with R on this data? Was it a simple classification problem like naive bias or something? गाइस आप सबने शायद कुछ इस पे एनालिसिस किया है, तो आई वांट टू अंडरस्टैंड दैट। कि इससे आपको हेल्प होगा कि एमनेस डेटा ये जो मैं दिखा रहा हूँ यहाँ पे, व्हाट इज द मीनिंग ऑफ ऑल दिस। Okay, Aditi, some people are saying they haven't done it. Some are saying they have done it. On support vector machine. Okay, okay, got it. But then the question is, ये डेटा तो एक 3x3 के मैट्रिक्स की फॉर्म में होता है, फिर आपने उसको यूज कैसे किया? बिकॉज अगर आपको क्लासिफिकेशन करना है निष्ठा, तो आपको तो इसको फ्लैट करना पड़ता है in the form of columns. Did you flatten that? Some people, I already
No,
know.
sir.
Okay, no problem, Nishtha, because I have already used this data for classification. तो मतलब I wanted to understand, ये जो डेटा है हम इसे क्लासिफिकेशन के लिए भी यूज कर सकते हैं, सिंपल ट्री मॉडल के लिए भी, बट उसके लिए हमें कुछ प्री प्रोसेसिंग करनी पड़ती है इस डेटा पे, हम डायरेक्टली यूज नहीं कर सकते। तो लेट मी एक्सप्लेन यू दैट। तो इमेज यहाँ दिखेंगे, ये सारी क्या है, आपके पास इमेजेस हैं। तो कल को आपको हर एक जो भी इमेज मिलती है, आपको उसको पहले एक मैट्रिक्स में कन्वर्ट करना है। जैसे कि आप वर्ड को वन हॉट एनकोड करते हो या एम्बेड करते हो, यहाँ पे भी करना है। ज्यादा वन हॉट एनकोडिंग कर लो या कुछ तो करो एटलीस्ट। तो आखिर यहाँ पर हम क्या करते हैं, यहाँ पर आप देखेंगे हर एक इमेज की पहले आपको पिक्सल्स इमेज है, ऐसा है। इफ गेट माय स्क्रीन, तो समझना बहुत जरूरी है। Understand that I have a 16 by 16 array. I may be this much. So let's say I have a, कितना हो गई, 1 2 3 5 6 7 8 9 10 11 12 13 14 16 16 बाई का एज है मेरे पास, ठीक है, आप स्क्रीन पर देखें। तो मतलब क्या है, टोटल 16 मल्टीप्लाइड बाई 16 मेरे पास सेल्स हैं, और हर एक सेल अपने आप में एक पिक्सल। अगर मुझे इस पर्टिकुलर इमेज का हाँ, ये आप देख रहे हैं, ये इमेज है 16 बाई 16 की। एवरी पिक्सल पोजीशन देयर विल बी अ नंबर, राइट, बिटवीन 0 से 255। तो इफ आई हैव अ नंबर, that means it's a light thing. If I don't have a number, means it's dark. Let's say all of these are zeros. All of these are zeros. But 258, it's a, everything is white. Okay, means white contains all the colors. So 255 everywhere. But if I say that let's say this represents a number, $255 here and 255 here. So this middle section is representing the number 1. Let's say it's all zeros, means this will be like this, black. Okay, or to be these as zeros, I can put these as zeros, means this is now making more sense, that okay, this is representing 1. Getting it guys, this is like representing 1. It is if it is 0, if this value is 0, means it will be black, means 1. So that means this image is the image for number 1. That's how your images are actually understood. Guys, is it getting clear? कोई भी इमेज जो होती है, मान लो ये 16x16 की है, हर पिक्सल पे एक नंबर होगा. 0 मींस लाइट नहीं है, वहां अंधेरा है. 255 मतलब बिल्कुल रोशनी है. बाकी सब बीच के कलर्स हैं. ओके, ये तो अब इस पूरी इमेज में जहां जहां पर 0 नंबर है वो एक्चुअली मैंने ब्लैक कर दिया है. ओके अदिति, इस पूरी इमेज में जहां जहां नंबर 000 था, जिन जिन सेल में, मैंने उनको ब्लैक कर दिया. तो अगर आप इसको देखें तो ये नंबर 1 लग रहा है आपको. अगर नंबर में बात करें, ये 7 भी हो सकता है, ये 1 भी हो सकता है, बट इट कैन नॉट बी 4, इट कैन नॉट बी 5, राइट. तो मतलब मुझे पता लग रहा है एज अ ह्यूमन हम कैसे इस चीज को पता लगाते हैं. Just forget about the numbers, just see that you are seeing a dark thing. Something dark is being visible to you, but computer does not know light or dark. Computer knows numbers. So that means you need to tell computer ki boss, wherever the number 0 is there, means that represents the edge for the image, edge detection. So this is sort of an edge detection algorithm. Okay, you are detecting edges. So it's a sort of a edge detection algo. We are detecting the edges of a image. So that's what our data represents. Let's go back to our data. So our data, every image, if you look at, is a 28x28 का image है. अब ये ब्लैक एंड व्हाइट, इसका ऑर्डर अलग हो सकता है, मेरा अलग हो सकता है. सो मॉडल विल लर्न इट. मैंने ब्लैक से एजेस निकाली हैं, वो व्हाइट से निकाल लेगा, बट दैट व्हाट मॉडल विल लर्न. इसने बस यहाँ उल्टा कर दिया है, ब्लैक एंड व्हाइट को व्हाइट एंड ब्लैक कर दिया, बट दैट कैन रियली बी अंडरस्टूड फ्रॉम दिस डेटा. सो लेट्स लुक एट द डेटा. So the data that I have is 60,000 images of 28x28 size. If you look at my train data, so I have these many rows. So this is a 3-dimensional thing, right? 3-dimensional means there will be like ये 20x28 के 60,000 ऑब्जेक्ट्स होंगे मेरे पास. गेटिंग इट? 28x28 के 60,000 इमेजेस. ये पहली इमेज है 28x28 की, ये दूसरी इमेज है, ये तीसरी इमेज है. ऐसे करते करते मेरे पास 60,000 इमेजेस हैं. गेटिंग इट? सो गुलजार, data we already know is 28x28, but even if you see, right, it's 28x28, 60,000 इमेज. टेस्ट डेटा में 10,000 इमेज. ठीक है गुलजार?
सर वो ठीक है. तो इस कोड से ये तो 28x28 इस कोड से कंप्यूट हुआ है.
किस कोड से? मतलब कुछ कंप्यूट नहीं हुआ यहाँ पे, ये तो ऑलरेडी नोन है हमारे पास. इंटरनेट पे एमनिस डेटा इस फॉर्म में ही होता है. हमने यहाँ डेटा बनाया नहीं है, हमें बना बनाया डेटा मिला है इस फॉर्म में.
मतलब ये 28x28 ये स्टैंडर्ड साइज उस फुट इमेज का स्टैंडर्ड.
हाँ, एमनिस्ट डेटा में हर इमेज 28x28 के पिक्सल की है. 28x28. जैसे आप यहाँ देखेंगे तो मेरी तो 16x16 की इमेज है, 16x16 की, बट वहां पर वो 28x28 की इमेजेस आपको दे रहा है, और ऐसी 60,000 इमेजेस दे रहा है. ठीक है? तो अगर मैं अपना ट्रेनिंग एक्स देखूं गुलजार, तो आप देखेंगे ये मेरी पहली इमेज है, ये मेरी दूसरी इमेज है, ठीक है, लेकिन अब क्वेश्चन तो 0 दिख रहा है क्योंकि वो डेटा कुछ इसमें गायब है ना, मतलब छुपा रखा है। तो मैं सिर्फ एक इमेज का डेटा देखने की कोशिश करता हूँ। सिर्फ एक इमेज का डेटा अगर मुझे देखना है, मुझे क्या करना पड़ेगा? मान लो मैं 0th इमेज देखना चाहता हूँ, तो ये 0th इमेज है, मतलब 0th मतलब पहली। तो आप ये देखें 28 तो कॉलम है, ये मतलब टोटल 28 कॉलम है, और ऐसी 28 मेरे पास ये रोज हैं पूरी नीचे तक, ये 28 रोज हैं। तो ये मेरे पास सारा डेटा है जिसमें कहीं कहीं पे मेरे पास जो जीरोज हैं मान लो वो ब्लैक है, और जो का नंबर है वो वाइट्स है। तो अगर इसको मैं आपको बताना चाहूँ ये क्या नंबर है, मुझे ये सारा डेटा कहीं पे कॉपी करना है। अभी ये क्या हो गया, नीचे थोड़ा ब्रेक हो गया है। So let me take it somewhere here. So if I take this data here, and if I try to show you how it will look, how it will look like. I will create that image if you just be here with me for 1 minute. Okay. So I'm not going into much formatting because it will take much time. If I try to understand this particular इसमें represent, it's simple that if you do some side, if you try to leave the remaining one, it's actually going at okay because of a particular it will try to make a 5 क्योंकि मैंने यहाँ पे वैल्यू बता रहे हैं। So now we know how our input is, our output is. Output is just a categorical category 0 1 2 3. It's not a number. Output is a category 0 1 2 3 4 5. मतलब 0 से लेके 9 तक के नंबर, मतलब 10 क्लासेस हैं. इनपुट हमें पता है हर एक मैट्रिक्स की फॉर्म में है. So now we will train our model. So to train this model, we will again go with Keras. We will create a sequential model, not a sequence model. It's a sequential just to add the layers. So these are all the layers. So Aditi, when we talk about data cleaning, we do data scaling, which we will talk about. Okay. So we will do data scaling. That's what we can do. Then there is something known as the RGB and the grayscale. Okay. So that are the things that we handle, whether it's a color image or a black and white image, or whether scaling is to be done or not. So we definitely scale our data. So we will do that. I'll talk about that in a while. So what we will do, we will scale all of these values somewhere between 0 to 1. Okay, because models normally are good with 0 and 1. So we will do scaling of all of these values and bring these values between 0 and 1. Okay. And also we will see a 2-dimensional versus 3D things. Okay. So now comes the most important part. When I am building the Keras, I need to talk about certain layers. And now here we are talking about some spatial layers. So to start with, the first layer is conv layer or the convolutional layer. Convolutional layers, we will understand what they do, but that's the most important part. And it's a 2-dimensional convolutional layer. Now we make it 3-dimensional. This is real image. तो इसकी एक जो पिक्सल वैल्यूज होती वो R की होती, एक जो पिक्सल वैल्यूज होती वो G की होती, और थर्ड जो होती, यस मिस्टर, कॉन्वोल्यूशनल मींस CNN के लिए वो, और एक BK होती. अभी लेकिन जो हम 0 से 255 की बात कर रहे हैं वो कलर की इंटेंसिटी बता रहे हैं, ठीक है, ऑन अ ग्रे स्केल. बट जब ये कलर इमेज होगी तो हमारे पास रेड के अलग इंटेंसिटी वैल्यूज होंगे, ग्रीन के अलग और ब्लू के अलग. तो अल्टीमेटली एवरी इमेज, इंस्टेड ऑफ a 2x2 image, it will be, मतलब ये 28x28 है, तो 28x28 के 3 मैट्रिक्स से वो रिप्रेजेंट. Okay. So Nishta, it all depends on the data, the way it is given to you, and it's all dependent on that. So here if you look at 28x28 का एक मैट्रिक्स है मेरे पास, अगर 28x28 के 3 मैट्रिक्स हो तो वो RGB मतलब रेड ग्रीन ब्लू को रिप्रेजेंट कर रहे हैं. So that means if you again look at this data, this is my 0th index is a 2-dimensional matrix. One more layer here, so you will understand. So 0 position है आपके पास, 3 मैट्रिक्स one more combo. Nishtha, getting it? So immediately competition और उसके बाद इस व्यू पे होता है काम कर रहे हैं any state है but there is color data also available here in will be like this. So my कर रही है Okay. So you can understand it simply like this, that you have this one matrix. You will have 28 by 28 का एक मैट्रिक्स है, फिर 1, 2 और 3 ऐसे 3 मैट्रिक्स होते हैं आपके पास RGB के लिए 28 by 28 के 3 जो आप करते हैं. ओके, मॉडल हर के 3 लेयर्स को प्रोसेस करता हुआ आगे बढ़ता बिकॉज ऑफ कलर. So now I know that okay, I have this image. Now I need to pass this data in the model. So I need to understand how model will behave. So how model will behave is all dependent upon the layers that I built. So definitely it's a grayscale convolutional 2D I'm using. There is pooling layer, which we will talk about, pooling layer. And there are two kinds of pooling, max pooling and average pooling. Here we are again doing max pooling in 2D. We can do average pooling also. Finally, we will use the dense layer. There will be dense layer. There will be some flatten operation and batch or normalization operation. Flatten, what we mean is, let's see how we are adding the layers. See, if you look at how my model is building, this is the image, a grayscale going to the convolutional layer, then through a pooling layer. Just leave this, I'll tell you this later. This is as I tell you, right, there are some optional things, some important things. Max pooling or average pooling. But now after this, I have to use a dense layer, say. Okay. And after this dense layer, this is dense layer, which is my output. इसके अंदर 10 क्यों है वैल्यू? क्योंकि मुझे 10 वैल्यूज प्रेडिक्ट करनी है, मतलब 10 कैटेगरी है मेरे पास. But now the point is, this is your convolutional layer, this is max pooling layer, this is your dense layer 1, and this is final dense layer. But between एनी कॉन्वोल्यूशनल लेयर और पूलिंग लेयर, अगर आपकी कॉन्वोल्यूशनल लेयर या पूलिंग लेयर के बाद आपको डेंस लेयर से कनेक्ट करना है, ओके, तो आपको फ्लैटनिंग करनी होती है। मतलब कॉन्वोल्यूशनल लेयर या पूलिंग लेयर ये स्पेशल लेयर्स हैं इमेज एनालिसिस के लिए। इनके बाद कभी भी कोई डेंस लेयर आप लगा रहे हो तो फ्लैटनिंग करनी है आपको। अब फ्लैटनिंग है क्या? कुछ भी नहीं है, आपका जो भी मतलब यहां से या नितिका यहां से जो भी आउटपुट जनरेट हो रहा है, अगर वो 2D है या 3D है, आप उसे 1D में कन्वर्ट कर दोगे। मान लो ये आपका 2 2 3 4 ये एक वैल्यू जनरेट हुई, फ्लैटन होने के बाद ये 2 2 3 4 एक 1 डायमेंशनल एरे में कन्वर्ट हो जाएगी। It's like you are doing flattening. Okay, so that's why if you see flattening does not have any parameters, it will just take everything whatever 2D 3D is coming, convert it into a 1D. Okay, but now we have to dive further. We know हमें convolutional layer use करनी है, 2D कब करनी है, 3D कब करनी है। We know कि pooling layer होगी, max pooling होगी, average pooling होगी, क्या होती है हम देखते हैं। फ्लैटनिंग लेयर होगी, फिर कुछ डेंस लेयर होंगी। डेंस लेयर ये ऑप्शनल है, आप चाहो तो रखो नहीं रखो, बट ये तो मैंडेटरी है, इसमें सॉफ्ट मैक्स होना चाहिए। इंटरमीडिएट में आप रेलू वगैरह कुछ भी कर सकते हो, हमें पता है। फाइनल में सॉफ्ट मैक्स करना पड़ेगा। लेयर के अंदर के पैरामीटर्स हमें पता है, ये वाले दिस वी विल टॉक अबाउट। एक नया पैरामीटर आपको दिख रहा है, बट अब यहां सबसे इंपॉर्टेंट चीज है कॉन्वोल्यूशनल लेयर को समझना कि आखिर ये 32 3 3 क्या है। ओके, so now let's understand what is this 32 and 3 3. So we will deep dive into the convolutional layers, but before I open up the convolutional layer, any question? What is con 2D, con 3D, max 2D, max pooling 3D, 2D, dense layer, flatten layer? Guys, any questions, or should I open up the convolutional layer? Guys, yes, no. Are you able to open this? Are you able to print up till this? Please print that thing. Wait, Gulzar. First of all, I want all of you to print this data, the MNIST data. मैंने आपको पहले ही कोड इसका भेज दिया था. Please show me if you are able to print this images. ये images आ रही हैं कि नहीं? ये images आप लोग print कर पा रहे हो कि नहीं? So what happens is in PyPlot there is this function image show, IM show, which is image show. अगर आपको कोई image plot करनी है, given the matrix, if you want to plot an image, see, I am just doing this, what? pyplot.im show, passing that passing what 0101 का जो 28 by 28 का मैट्रिक्स है, और उसको एक कलर मैप दे दिया कि भैया ये ग्रे स्केल का इमेज है। तो यू कैन सी दैट ये ऊपर वाला जो 5 वाला है, मैंने बस उसी को अलग से प्लॉट करा है। प्लीज कंफर्म इफ यू गाइज आर एबल टू डू दैट। मैं ग्रे स्केल में प्रिंट कर रहा था, नहीं तो फिर मैंने उसको स्केल नहीं दिया तो उसने अपने हिसाब से जो डिफॉल्ट स्केल है वो कलर स्केल पे प्रिंट कर दिया उसने। बट अब आप देखेंगे तो फिर बहुत सारे कलर वैल्यूज हो गई हैं। I know that this is a grayscale image, so put it like that. Okay. Now, once you have this thing, we know about the images also, but the we also know the input also. But again, the target was values 1, 2, 3, 4, 5 like that. So we will again use two categorical. Remember, we converted the output in RNN also using two categorical. Here also we will do that because this models they generate vectors. So okay. तान्या जब भी हम पाइप अच्छा तान्या आस्किंग व्हाट इज द सी मैप जब भी हम पाइप में कुछ इमेज प्लॉट करते हैं या कोई भी ग्राफ भी हम बनाते हैं तो उसमें हमें कलर मैप होता है जैसे आपके पास जीजी प्लॉट या जीजी एस्थेटिक्स होते थे यहाँ पर कलर मैप है जिसमें आप अपना पाइप प्लॉट से कलर मैप बता सकते हो ये ग्रे स्केल का कलर मैप है बाय डिफॉल्ट देयर इज दिस आई थिंक रेनबो कलर मैप तो वो कलर उस हिसाब से दिखा देता है बट हम इमेज उस फॉर्म में देखना चाहते हैं जैसी वो है वरना वो 0 से 255 के नंबर देख के वो उनको कलर देना शुरू कर देता है okay okay so now we 313 subplot so Nitika, this is all about the dimensions of the subplot that we want. So yeah, I'll tell you, Gulzara. That subplots when we have to plot, you remember, right? When we have to plot multiple images, we do this subplotting on the same screen. When you want to we do subplotting. I'll tell you. Okay, let's move to this modeling. So if you want to print only 4 images, 5 images, you can accordingly change that subplot. Or if you, I don't want to keep you confused. So if you are interested, let's do that also. So I'm not going there. Let me rather use it here only. Must be 3-digit. So if you remember, we did this thing earlier also. 1 minute. So what happens is this 332 represents what? For example, this means you are creating a 3 by 3 matrix in which at the position 2 you want this plot. Okay, let me do this again. So if you look at this, are you able to recall? We did this long back, I think. So guys, what happens is if I am saying 3 3 1 means 3 by 3 का एक मैट्रिक्स बनाओ, राइट? अब उसमें वो इमेज किस पोजीशन पे डालनी है, तो इट्स लाइक 1 2 3 4 5 9. So on the position 1 2 3, which position I want, so I say, oh, put it at the position 9. So it's coming at this particular location. Okay, तो वो आपका सब प्लॉट ऐसा रहता है. So it all depends upon the number of images you want to plot. So if you look here, here what we are doing is 3 by 3 because we want to print 9 images, right? I am saying only show 9 images on a 3 by 3 scale. But which cell to put which image in is decided by this I. तो वो incremental number रहेगा. Okay, and here we don't start with 0, we rather start with 1. That's why it's 1. ओके, नाउ इवन मतलब आप 3 3 1 भी कह दो तो मतलब पहली इमेज 3 3 1 पोजीशन पे प्लॉट होगी, फिर 3 3 2 3 4 इस तरह से. ठीक है, सो दिस इज योर मैप, दिस इज योर सब प्लॉट्स. मतलब ये पूरे प्लॉट में 9 सब प्लॉट्स बन गए. ओके, so now let's start with the layering. So we have to use these, we have to only understand these two things and we are done. We have to understand convolutional layers and the pooling layers. Everything else is like fine, but now let's understand these layers. Okay guys, so here it starts. If you look at my screen, you are aware by now that this is what your input, image, which is having certain numbers, where these numbers are nothing but the intensity of the light at that position on the gray scale, not on the color scale. So this is a 6 by 6 input image. Whenever you pass the input image to the model, the very first layer we use is the convolutional layer, where we use a 3 by 3 filter. So what I'm doing, I'm using a filter which is also known as a kernel. So I'm using a filter or a kernel in the convolutional layer, and the shape of that kernel is 3 by 3. It can be 5 by 5, 7 by 7. It is always odd. There is a reason behind it, I'll tell you. It's always odd. मतलब 3 by 3 होगा, 4 by 4 नहीं होगा. और स्क्वायर मैट्रिक्स होगा तो मतलब 3 by 3, 5 by 5, 7 by 7, 1 by 1, 1 by 1 भी होता है, वो एक स्पेशल केस होता है. But you are getting it. So in the convolutional layer, we have to tell our filter that what my filter is. So if we go back and we look here, and you are using a 3 by 3, what you are using a 3 by 3 kernel. I'll tell you what this is. Just put it on the side for the time being. This is your filter. Then this is your input shape. 28 by 28 by 1. मतलब 28 by 28 का एक मैट्रिक्स है, ग्रे स्केल. अगर कलर होता तो 3 डालते हैं, RGB के लिए 3 वैल्यू डालते हैं. 28 by 28 और 3, 1 की जगह 3. तो अभी आपको ये क्लियर हो गया. आपको ये तो पता ही है वैल्यू. वी विल टॉक अबाउट दिस कर्नल इनिशियलाइजर, बट दिस इज योर कर्नल. Now the point is, what should be the initial value in this kernel? That is decided by this kernel initializer. And the algorithm initial approach is He uniform. So the HE uniform. So what I mean by that is the value that you see inside this filter is 1 1 1 0 0 0 -1 -1 -1. ये वैल्यू कहां से आई, तो वो इनिशियल वैल्यूज कुछ भी हो सकती हैं जो हमारा इनिशियलाइजर डिसाइड करेगा। एंड अल्टीमेटली जो CNN मॉडल को ट्रेन करने की प्रक्रिया है वो यही है कि एट द एंड ऑफ द प्रोसेस इन की फाइनल वैल्यू क्या हो। तो अल्टीमेटली गाइज this is weight 1, weight 2, weight 3, weight 4, 5, 6, 7, 8. So you are learning 9 weights in your model. Is it clear? Before I go ahead, that convolutional layer में एक filter होगा जिसको हम कर्नल कहते हैं, उसकी कुछ वैल्यूज होंगी जो इनिशियलाइज होंगी, बट मॉडल जब फॉरवर्ड बैकवर्ड प्रोपोगेशन से जाएगा, ग्रेडियंट डिसेंट वगैरह सब होगा यहाँ पे, तो ये वेट्स ही लर्न किए जाएंगे। इतना क्लियर है? बिफोर वी गो इनटू ये दोनों के बीच में ये मल्टीप्लाई कैसे होने वाला है, या नितिका, आई एम सेइंग दैट दिस फिल्टर you have to decide whether you want 3 by 3, 5 by 5, 7 by 7. I will tell you the logic later, but understand that this will always be a square matrix of odd dimensions, 3 by 3, 5 by 5, 7 by 7, 9 by 9 is very rare, but yeah, 7 by 7 is good enough. तो टोटल इसके अंदर अगर ये 5 by 5 होता तो 25 वेट्स होते, और वो 25 वेट्स इनिशियलाइज कौन करता, ये कर्नल इनिशियलाइजर, तो इसीलिए इसको कुछ लोग कर्नल कह देते हैं इंस्टेड ऑफ अ फिल्टर। नितिका, गेटिंग इट? परफेक्ट। I'm coming to that, Gulzar, I'm coming to that. So now the second point, that you decided the dimension of the filter, the initial value for the filter. Now model will learn it and tune it. But how model will work? Model will do input convolution. Convolution is another matrix operation, which is very simple. You will start with this पार्ट। अल्टीमेटली आपको करना क्या है, आपको फिल्टर को सेट करना है अपनी इमेज पे। एक ऐसे इसको एक आप चश्मे से देख रहे हो, एक फिल्टर से देख रहे हो, आपकी इमेज के ऊपर आपने एक ये फिल्टर लगा दिया, छान रहे हो इमेज। पहली सेक्शन होगा 3 by 3, यहाँ पर इसके ऊपर आपका फिल्टर मान लो, ऐसे फिल्टर उठा के ये वाला उठा के यहाँ रख दिया, तो ये क्वेश्चन हो गया। और आपस जो मैथमेटिकल ऑपरेशन होगा उसका आउटपुट, ठीक है? okay. आपका ये जो फिल्टर है ये इतने पे चल चुका है, अब वो इस पार्ट पे चलेगा, इस पार्ट पे सरक गया, एक लेवल से आगे सरक गया, इसको हम कहते हैं स्ट्राइड। आई एम पिंकिंग यू, दिस इज नोन एज स्ट्राइड। बाय डिफॉल्ट वी हैव अ स्ट्राइड ऑफ 1, वी कैन इंक्रीज इट, मतलब आप कितने कितने विंडो से सरका रहे हो, ठीक है? अब आपका इस पे कुछ मैथमेटिकल ऑपरेशन होगा इसके साथ, तो वैल्यू आई -4। फिर आपका स्ट्राइड एक लेवल से बढ़ेगा, और ये अब इसके साथ इसका मैथमेटिकल ऑपरेशन हुआ, वैल्यू आई 0। फिर इस ब्लू वाले के साथ इसका कन्वोल्यूशन होगा, और जो वैल्यू आप यहां देख रहे हो 8 ये आई। लेकिन अब इसके बाद जब ये सरकेगा तो ये फ्रेम से बाहर चला गया इतना पार्ट, तो ये वाला ऑपरेशन नहीं होगा, मतलब अब वो नीचे सरक जाएगा इधर, ये वाला पार्ट। अब इस वाले पार्ट का ये जो पार्ट है इसका इसके साथ कन्वोल्यूशन होगा और ये वैल्यू आएगी, फिर ये ऐसे सरकता जाएगा, ये भरता चला जाएगा। इतना क्लियर है? बिफोर आई टेल यू कि फॉर्मूला क्या है गाइज, ये लेफ्ट से राइट पे वैल्यू कैसे फिल हो रही है, क्लियर है? करण, अदिति, गोमिनी, guys please, Rahul, you guys are there. Perfect. So now We will talk about that subscript, superscripts, Gulzar. Just a minute.
And
You are asking about this. I'll tell you. Wait.
वो तो ठीक है.
हाँ, और बताओ.
अभी आपने जो वैल्यूज नीचे आने का जो बताया था एक बार, वो नहीं क्लियर हो रहा.
हाँ हाँ, मैं आ रहा हूँ उस पर, अभी क्लियर हो जाएगा. अब देखो, अब हम शुरू से चलते हैं. ओरिजिनल मैट्रिक्स है, ये मेरा फिल्टर है, इससे ये नया मैट्रिक्स बनने वाला है 4x4 का. तो आखिर इसमें वैल्यू कैसे फिल होंगी देखते हैं. दिस विल बी convolved with this. This value 3 will be multiplied by 1, 0 will be multiplied by 0, 1 will be multiplied by 1. मतलब जो जिस पोजीशन पे उससे मल्टीप्लाई हो जाएगा और एंड में सबको ऐड कर देंगे तो वैल्यू आ गई -5. गाइज, इज इट क्लियर? सिमिलरली गुलजार, अगर आप यहां देखो तो ये किसकी वैल्यू दे रहा है आपको? जो सबसे लास्ट वाला है. ठीक है, जो सबसे लास्ट वाला है. तो उसमें क्या हुआ, ये 1, 0, -1, ये एक्चुअली इन्हीं वैल्यूज को ऊपर दिखा दिया गया सबस्क्रिप्ट्स में, सुपरस्क्रिप्ट्स में, सॉरी. 2 multiplied by 1 plus 7 multiplied by 0 plus 4 multiplied by -1 plus and you keep filling these values. गुलजार, अभी क्लियर हुआ क्या? गुलजार, टेल मी व्हाट इज द रिमेनिंग डाउट, आई विल क्लियर इट. अब इसके बाद क्या डाउट है? परफेक्ट गुलजार, थैंक्स अ लॉट. तो एक तरह से आप समझे मेरी बात, राइट? कि सॉरी, तो मैं ये कह रहा हूं आपको वन सेकेंड. हाँ, मैं कह रहा हूँ ये आपका क्या है गुलजार? दिस इज योर frame, right? So you will first this here, on this, then on this 3, then on this. You will keep sliding it. Then it will come here. Then you keep sliding like that. Okay? बड़ा अजीब सा हो गया, कहाँ भाग गया? हाँ. Okay guys, I hope that is clear now. ठीक है, वो इमेज उतना छोटा नहीं हो रहा है जितना I wanted it to be. Okay, वो बंद ही हो गया. That's fine. So now you guys are able to see like what's happening behind the scene. What happened here? This we don't need it. So this is known as convolutional operation, where you do element wise multiplications and then add it, and then you get to the convolutional layer. Now the question is why we do this. Why we do this is, first, this helps us in reducing the number of weights that model need to learn. Otherwise, the number of weights that model need to learn will be too many. It will explode. So this helps us to control the number of weights. Second, it also helps us to identify the edges or the angles in the image, if there are edges or angles. For example, if you talk about this kernel is having this as what? The light color, right? This is the light color, this is the dark color, right? So एक तरह से ये एक dark edges आपके identify करने की कोशिश कर रहा है. So this kernel actually helps us to identify the sections of the images, and they keep sliding or striding. So we can change another parameter known as a stride parameter, which is available there. My anaconda just stopped, so I'm just starting it in. Okay. So by now you are clear with layer is one have filters which will be applied striding another. You keep stride as one, you keep stride as two. There are reasons behind talk about, but there is third important concept which is known as padding. So in the convolutional layer, we specify the filter, but then we also specify striding, and then we specify the padding. Now what is padding? So let's see this. What is this padding? So before you go into padding, you should understand, again, this is a numerical question. Given a input matrix of n by n and a filter of f by f, can you tell me the output of a convolutional layer, the size of the output? So yes, there is a formula which is n minus of f plus 1. So this is the formula. So guys, keeping this formula in mind, if you come back here, how will you decide? Tomorrow this image can be a 60 by 60 image, and you can still use a 3 by 3 ka filter. Can anyone tell me the dimension? So 3 by 3 matlab f cross f. F cross f. 60 by 60 means n cross n. These are numerical questions, okay? That comes in objectives. Okay. So it's n plus minus f plus 1. Okay. So that is 58, means 58 by 58 are the total calculations. These many calculations will happen. So the bigger the size of your input image, more the calculations will happen. But 58 by 58 is the calculations that are happening. But the weights are still 9. Still, the weights that model learns is 9. They can confuse you in interview that I had a 6 by 6 image with 3 by 3 filter. Total 9 weights were there. Now I increase this to 60 by 60, keeping the filter same. Now how much will be the weights? So the options is there is no correlation of this as such with the weights. Weights will be 3 by 3 as in 9. Does not depends upon the input as in. Okay, but there is one important thing to remember is image size should not be smaller than the filter size. Okay. Makes sense, right? Or you have any doubt? Image size, can it be smaller than filter? What do you say? Yes, no? Perfect. Okay. It cannot be, because I told you if at this position there is this out things, we don't consider it, right? So if image itself is only this much, everything is out of, nothing will happen, no striding will happen, nothing will happen. Okay. So keeping that in mind with the formula and everything, so what is padding? See, what happens is in the padding, I say I want to pad p is equal to 1. Padding p is equal to 1. So that means मेरा जो इनपुट है उसमें मैं जीरोस पैड कर रहा हूं चारों तरफ. अगर p इज इक्वल टू 2 है तो मैं 2 लेयर ऑफ जीरोस को पैड कर रहा हूं चारों तरफ. पैडिंग हम एनएलपी में भी करते हैं. एनएलपी में भी पैडिंग की जाती है और सेम ही रीजन है जो वहां है वही यहां है. तो आप थोड़ा पढ़ना पैडिंग इन वर्ड रिप्रेजेंटेशन और वर्ड एम्बेडिंग वहां पे भी की जाती है। तो उसका कारण क्या है? उसका कारण ये है कि भाई देखो, स्ट्राइड्स कर रहे हो, लेट्स टेक अबाउट दिस, व्हेन यू आर स्ट्राइडिंग, you are doing convolution. Okay, you are doing convolution of this. Okay, you keep doing convolutions, but the edge अपनी बात यूं होती है जो बीच के आप इतने जितने भी स्ट्राइड्स बनाए, इवन आप अगर ये वाली वैल्यू देखें, फॉर एग्जांपल 3 स्ट्राइड्स, ये 3, राइट? तो वो है एक पर्टिकुलर चीज तो ऐसी कंट्रीब्यूट कर रही है आपकी प्रेडिक्शंस में। एक तरह एक सेक्शन आपका इमेज का ऐसा है जो कि बहुत कम कंट्रीब्यूट कर रहा है। तो इससे क्या हुआ, एक तो आपकी इंफॉर्मेशन लॉस्ट हो रही है, कुछ इंफॉर्मेशन जो उतनी बार यूज जितनी बार बाकी हो रही है, तो दैट मीन्स देयर इज सम प्रॉब्लम। कैन आई डू समथिंग टू मेक दिस कंट्रीब्यूशन बिगर? यस, इफ आई पुट another layer of zeros here, then my strides will start from here and 3 will become part of it, plus इसके ऊपर भी एक बन जाएगा, तो 3 will become part of so many strides. So that means I am making sure my information is not lost, क्योंकि कई बार हो सकता है एज पे जो एकदम इंफॉर्मेशन है वो बहुत इंपॉर्टेंट थी, जो भी कलर या कुछ वो रिप्रेजेंट कर रही थी। तो दैट्स व्हाट पैडिंग इज। पैडिंग बाय लेयर 1, लेयर 2, लेयर 3 वो जीरोस पुट कर देती है चारों तरफ ओरिजिनल मैट्रिक्स से, लेकिन क्योंकि आपने अब पैडिंग कर दी, आपका जो आउटपुट वेक्टर है या आउटपुट मैट्रिक्स है वो बढ़ जाएगा। बट फॉर्मूला अभी सेम ही है, फॉर्मूला अभी सेम ही है। 6/6 में अगर आप पैडिंग कर दोगे, मान लो p = 2, तो वो 8/8 का हो जाएगा। तो इट्स लाइक 8 माइनस ऑफ f प्लस 1, तो 8 माइनस ऑफ 3 इज व्हाट, 5 प्लस 1 विच इज 6, तो 6/6। या आदिति, जीरोस आर पैडेड चारों तरफ, जीरो चारों तरफ लगाते हैं मैट्रिक्स के, जो इनपुट मैट्रिक्स है। ओके, अब क्योंकि पैडिंग की बात उठी है, तो पैडिंग इन वर्ड्स मैं बता ही देता हूं यहाँ पे, so that you can understand this. Okay. Um, let's take an example. To build your text. If can you tell me what is this? Can anyone tell me what is this? You input. Can anyone tell me what is this in NLP? Audible? Am I audible? Okay, I am asking you. NLP मॉडल में मैं ट्रेन कर रहा हूँ, ये लेफ्ट साइड पे 2 इनपुट है, ये बीच वाला क्या है? हाँ है, टोकनाइजेशन से जो सीक्वेंसेस निकलते हैं, राइट? नहीं हिडन लेयर नहीं है गुलजार, हर बार किया गया ना, ये आपको वर्ड एम्बेडिंग में रहेगा। अभी एम्बेडिंग नहीं है, बट ये क्या है, वर्ड के टोकन जनरेट किए हैं आपने गुलजार, दिस इज नॉट हिडन लेयर गाइस, इज इट क्लियर? जो टोकनाइजेशन की मतलब वो मतलब इतना ये है आपके जो वर्ड टर्म्स हैं, जो आपने वर्ड हर किए है, राइट? नो टू ऑल so yes, you are interested in getting items on our area. You want to create items, so the mouse will come, then mouse ran up with, तो the जो है वो मल्टीपल इसमें आ गए। ट्राइग्राम में भी ये प्रॉब्लम होती कि आपका जो द था या जो क्लॉक था, जो एडिट वो एक बायोग्राम या ट्राइग्राम का पार्ट, डेटा मल्टीपल बायोग्राम्स या ट्राइग्राम्स का पार्ट बनता, जिससे कि आपकी इंफॉर्मेशन लॉस्ट हो रही है। फिर से क्लॉक एक ही बार आ रहा है जबकि माउस मल्टीपल बार आ रहा है। हो सकता था कि क्लॉक यहाँ पे मेरे पास कंटेक्स्ट में कुछ इंपॉर्टेंट रोल प्ले करता है, राइट? तो दैट्स व्हाट इवन द पैडिंग देयर हैपेंस, द पैड it with initially 0 here and 0 here. So किसी भी वर्ड को जब हम इनपुट भेजते हैं, हम पैड करके भेजते हैं एंड में, जो अभी मल्टीपल बायोग्राम्स या ट्राइग्राम्स का पार्ट होता है, डेफिनेटली 0 and the and clock 0 will become diagram, but two separate model. So वेट बढ़ गया उस आपके मॉडल में। आर यू गेटिंग दैट नाउ? ये जो सीक्वेंस है, this 1 2 3 4 5 represents just this. ये जो सीक्वेंस है, and this is the embedding layer, and with dimension of 4, each vector is represented by 4 features. So 1 will be represented by 4 features, 2 features, 3 is represented by 4 features, 1 मतलब 1 again and then 5. So guys, ये आर्किटेक्चर समझ आ रहा है? ये क्या है? ये क्लियर है सबको? It's simple that the training phase of the model, right? You create an embedding, you create a token dictionary of tokens. This is the dictionary of tokens, and this is the embedding, the embedding layer, which takes certain inputs, generates the output based on the number of dimensions, output dimensions. The pattern that happens Nitha have been like you need a here, मतलब ये सब तो ऐसे ही रहेगा, मतलब यहाँ तक तो सब ऐसे ही रहेगा। Before the embedding layer, I put a padding. You can उसके पहले 3 लेकिन मैं पहले 2 अब 0 नहीं होता, यहाँ केस है which is like fine. Up 0 mostly we give space, but then this and then it will keep creating on the right hand side. Guys, clear how pattern happens. Let me do this. Nitika, actually patterns. So it all depends कि आप मॉडल को क्या कर रहे हो. Okay. That क्या मॉडल डायग्राम हो ट्राइग्राम उस लेवल पे ये काम है. But yeah, that's the patterns. So padding is another important concept, both but let's see striding convolutions. It's nothing but you first take this, then on this side of the data, you keep moving, right? But if it's a stride of 2, if it's a stride of, if you're saying okay, stride by 2, so you will first create this matrix, multiply by this or convolve with this, then instead of taking start करोगे और स्ट्राइड्स करोगे और नीचे जाते हुए भी आप ये यहां से स्टार्ट ये स्टार्ट ना करके आप यहां से ये वाला लोगे, ये वाला, this one you will start with this one. Okay, yeah Gulzar, so this is what your striding is.
एक्चुअली इस डायग्राम के बारे में एक क्वेश्चन था भी जो आपने गूगल.
हाँ ये वाला.
यस सर.
बोलो
सर यही जो ब्लू कॉलम जो है
हाँ
कि मतलब
ये ब्लू क्या है, ये ब्लू आपका टोकनाइजर है. ये लेफ्ट से जितने भी वर्ड्स हैं उनमें से यूनिक वर्ड्स लेगा, ठीक है, सारे यूनिक वर्ड्स लिए और सबको एक नंबर असाइन कर दिया.
ठीक है सर.
ठीक है,
सर
देखो
जो
जैसे सिर्फ एक ही बार आएगा, मल्टीपल बार नहीं आएगा.
ठीक है
ठीक
सर, ये
है,
तो ठीक है.
और
और जो
ये नंबरिंग कोई अल्फाबेटिकल ऑर्डर में नहीं होती, वर्ड के जब वो वर्ड अकर किया वो नंबर मिल गया. हाँ बोलो.
मतलब ये वर्ड के सीक्वेंस में ही है ना?
हाँ बिल्कुल, बट अल्फाबेटिकल नहीं है.
ठीक है. और सर जो ये राइट के 2 बॉक्सेस हैं, एक बार वो नहीं क्लियर हो रहा.
गुलजार, you can go through it. ठीक है, read it. Let me send over this link to you. ठीक है, this is from this is a Google's machine learning link. I'm sending you this link. You can go through it. Okay. So now the point is, we know what is a convolutional layer, what is a convolution, what is a filter, what is striding, and what is padding. So now we will see tomorrow, like on what basis we decide the filter size, on what basis we decide the strides and the paddings. Okay, but padding definitely helps you to save some of the information जो कि otherwise lost हो जाती. So these are the things. And Harshita, the striding depends on a lot of the things. One of them is if you have a very big image, then you don't want to generate a very big matrix. You want to generate still a small matrix, so you can stride bigger strides, give bigger strides, so that you can generate a smaller matrix. You want to avoid too many calculations. But with that, you should be aware that you are not losing the information, because more strides also result in losing the information, right? Nishtha, we are not doing flattening. This is all convolutional. Flattening is just to convert it into one-dimensional thing. Flattening is just a simple thing. Okay. We are doing convolve. This is convolve operation. This is known as convolve. You say involve someone. So convolve this on this. Involve, convolve. We are convolving it. Okay. Because bigger strides actually reduces the output dimension, this thing. Okay. So that was one thing. So now just have a look at this. I'll explain you further tomorrow also. But this is what I was saying. This is a 6x6 matrix, but 3 layers, as in RGB, red, green, blue. Just see on this side. So then we have a filter, which is like a 3x3 filter, but then 3 filters of 3x3 for these layers. Each of these layers, we have these 3x3 filters. So in this case, model will learn how many weights? 3 multiplied by 3 multiplied by 3. So total kitna hota hai? 27, I think. So that many weights the model will learn and adjust them through back propagations. So in the next layers, I am passing it to the ReLU layer, or maybe some dense layer. Okay, from this I'm generating some outputs. So I'll explain you all this tomorrow, and what this additional layer is, which is something else. We'll talk about it. But with that, we will also talk about pooling. Like this is convolutional layer. We will talk about pooling, max pooling and average pooling tomorrow. So guys, what you need to do is read about padding, read about activation functions. Please be very clear on this. Read about kernel initializer further. What is this HE uniform? Like this decides the initial value of the weights in your kernel or the filter. Okay, and just see the color representation. As far as I remember, there is MNIST color data also. Like we have MNIST data, right? There is this MNIST color data also. Let me show you. So if you look at this, right, MNIST has also given their color data. So you can import their color data also. There is a separate data set for that, which they have given, so as to understand the colors, which is also available. But first implement the non-color one, grayscale, and then go to the color data. Okay, so before we end the class today, any question, any last questions? Tomorrow we will talk about pooling. Guys, any questions? Any questions in your mind, or I may not have answered any questions you have asked it earlier. अगर आपने चैट पे कुछ पूछा हो जो मैंने आंसर नहीं किया हो. So I'll take it as no questions, but again I want you guys to study what? Study about RBMs. I'll put this notebook also. Study about this. Okay, before I end the class, let me show you these architectures. Lee CNN, these are different architectures. So I'll explain you this tomorrow, but Lee CNN is one of the architecture. Then you have this LXNet model. These are all different architectures. Okay, like what this particular researcher think about implementing a CNN. Then you have VGG. So these are all different architectures. Now ResNet, or the residual network, is becoming very famous. So this is what a ResNet architecture is. And then there is this inception model architecture. Model. Inception model. इंसेप्शन मॉडल बहुत सारे परम्यूटेशन करता है किस चीज के फिल्टर्स के मतलब इंसेप्शन मॉडल होता है वो 3x3 5x5 7x7 ऐसे डिफरेंट फिल्टर्स ट्राई करता है वो एक उसके माइंड में कुछ इंसेप्शंस होती हैं इट ट्राई टू फाइंड आउट द बेस्ट वन तो इट्स बिट more time consuming and complex look at coming more and more it try multiple things convolutions average pooling max pooling it tries multiple things if you see कि ये multiple branching break हो गया then again it's concatenating branching so you have these inception models so just look at those they are just different researchers published papers okay so I'll put these things so second being those advised us to study so that's what I'm putting this notebook Gulzar Nishta so if you have any question for me you can ask yeah Damini so you can separately call or talk okay guys so any questions last questions Rahul Aditi Pragisha
सर
yeah Gulzar tell me
सर कई बार आपने जो एक क्लास में आपने इन पीपीटीज के लिए डेमोन्स्ट्रेट करके दिखाया था कि आपके गिटहब में से डाउनलोड करने का तो जब मैं एक्सेस हो नहीं पा रही मुझसे ये कई दिन से सर
नहीं तो आप ये करो ना मैंने आपको तो बताया था सिंपल सा तरीका सी
यस सर आप किसी अकाउंट से ट्राई किया था
फॉलो अलोंग विद क्या किया था
मैंने ट्राई किया था
हाँ मैं बता रहा हूँ आपको लेट्स फॉलो अलोंग क्या प्रॉब्लम हो रही है और अभी उसको कर लेते हैं रेस्ट पीपल यू कैन ड्रॉप गुलजार यू आर द प्रेजेंटर
Sir?
Yes, who's this? Yeah, Nishta, tell me.
Sir, actually, we wanted a break for this week since the festivals are coming. So we wanted to talk to Damini ma'am and you about the permission.
हाँ तो निष्ठा मतलब take a break मतलब from my side there is no point of not giving a break. You talk to Damini, but yeah, we will have a class tomorrow because that's my last class. Then maybe the another trainer who is going to come with his subject may start after the festivals.
Sir,
Okay.
actually, the topics you are teaching, we will also get a time to revise them for the last class. So just in case we have doubts, so we can ask you. So that is why
Yeah,
when
yeah. So see, my course will be over tomorrow, and then if you want to take a break, take a break. And if you want a doubt class, we can arrange that separately after 1 or 2 weeks. आप लोग सब practice कर लो जितना भी करना है. फिर एक common doubt class में I'll tell you everything. Yeah. So but tomorrow officially our course will be over, and then I will give you a doubt class whenever you guys say that we are ready with the doubts. I'll give you. But what my point is now Damini need to check for the another trainer when he will start your course and then
So
you can talk to Damini. Okay,
So you won't be teaching us Hadoop?
that's what Nishta I don't know what is the next course, what is the next plan. So Damini is the right person. Right now, I cannot comment on that. Like, what is your next things they have planned, right? So if I am the one, definitely I'll be the one. But then it will be a separate line altogether. If I'm teaching Hadoop, we will not be discussing machine learning in that. You consider that I so consider it like that. So
Yes,
that's my
sir.
point. Okay. So Damini will tell you, but yeah, you guys can reach out to me for any doubts anytime over emails, and we will arrange your doubt classes whenever you want. So don't worry about that at all. So yeah, Gulzar, you can share your screen. I'm waiting.
अभी जो आपने राइट दिया था तब जो कनेक्शन लूज हो गया था मुझसे भी।
यार अब तो मेरे पास भी नहीं है राइट, अब तो दामिनी दे पाएंगी।
मतलब जब
आपके
मैं
है
करने लगा था तभी
नहीं,
कनेक्शन लूज हो गया।
नहीं आप 2 अकाउंट से लॉग्ड इन हो, आई थिंक आपके दूसरे अकाउंट पे है स्क्रीन शेयरिंग, राइट?
अच्छा ठीक है सर, एक बार आप अकाउंट पिंग कर दो, मैं उससे ट्राई करता हूँ।
आप ऐसा करो गुलजार आप मुझे अपना ईमेल आईडी पिंग करो, मैं आपको ईमेल कर देता हूँ वो पीपीटी। कौन सी पीपीटी देखनी है आपको?
सर जो भी आपने क्लास पे कराई है अभी तक, जो इस महीने भर में पिछले महीने से।
अच्छा अच्छा, यह सब कुछ है वहां पे। आई डोंट नो आपको क्यों नहीं मिल रही।
पर वही जो डाउनलोड की ऑप्शन है वो।
इफ समवन इज ऑन द कॉल प्लीज मेक मी द प्रेजेंटर। निष्ठा आप हाँ आप पूछ लीजिए दामिनी से आपकी नेक्स्ट क्लासेस कब से हैं, और गो फॉर द हॉलीडे वेकेशंस। शी विल हेल्प यू डेफिनेटली। मींस आई डोंट हैव एनी प्रॉब्लम, मुझे तो खुद छुट्टियां चाहिए। आई एम हैप्पी विद दैट। Gulzar, I'll call you. I'll call you separately after this call. गुलजार आप मुझे कॉल कर लो। आपके पास मेरा नंबर होगा शायद।
अभी 1 मिनट में करता हूँ कॉल अभी।
हाँ 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 ठीक है। ओके गाइस, थैंक यू, थैंक्स अ लॉट।